of the memory. And there's also none, which we will see. I don't want to go into the details now, but just keep in mind that none itself is a constant, and it's a special one as well. There are these things which probably you notice that look like proper language, like 3 cats and hi there. But the way in which we express this in Python, when we want to express that these are constants or things that are set in stone and not some instructions for the computer, some weird instructions for the computer, is by putting the quotes. So the moment you put it between quotes, anything, that's a signal for your computer that these should be treated as a bunch of letters that together make sense. Might not have to make sense, but at least from our perspective, or most of what we'll do, it will make sense in the language that you use on a day-to-day basis, and not in a programming language sense. And the last one on the bottom is a list. So if you want to put together a bunch of things and you want to say that these things go together or in some particular order, then you put them in a list, and that also is considered one of the constants in your work. The second color in the palette is that of the variables. So these things, I mean, if you look at it, they kind of look like regular language, but they're not really between quotes. If anything, they have this weird thing where you have to put the underscore. So just to understand the way that the language kind of works is that we use white spaces to separate things that might be interesting for the programming language. And because of that, whenever I want to say that a bunch of things go together to represent a variable, I have to use an underscore instead of a space. So that's kind of the trick that you go around with. So these things kind of, you put together things, you give a name to a variable, and the reason it's called a variable because these are tokens that will represent some piece of memory. So whenever I say temperature, then the programming language will set aside a piece of memory and say, from now on, every time you say temperature, I will know that you mean that particular piece of memory that I reserved for temperature. But that one, it's not set in stone like constants, because that piece of memory might change. And if anything, your purpose when you program is to actually change these variables and make them variable and change over time so that interesting things happen, right? So there's temperature, color 1, my name, first number, whatever you want to do, as long as you keep in mind that things have to be glued together with underscores. There are other rules to the name, the ways in which you can create variables, but we'll go as we go along, we'll learn other rules as well. If anything, whenever you get an error, you might come back to us and we'll tell you, oh, your variable name is wrong, and you should do this to fix it. The third category is what we call operators. So these are definitely completely different from everything that you've seen on the left side. And here, these are things that basically, you can think of it as it matches your intuition of what you would do when you're take a course of mathematics. Multiplication, addition, division. We have some other ways in creating some special operators where we put division twice, and that has a completely different meaning than division itself. We use star as a way to do exponentiation instead of multiplication. There's equal, there's equal. So there's a bunch of them that we will go over. And essentially, these things are ways in which you change your variables. So these are ways in saying, well, you know what, the temperature, I want to increase it. So the way to write that is by saying temperature plus something, right? So that's how you would say that temperature increases by some amount. If it's a constant, then you say plus 5. But anyway, this is the purpose of the operators is to change the variables themselves. So they're very, very, very important for everything that we do. And last but not least is functions. Right? This is basically the more we advance in our use of Python, the more we realize that people have already thought about ways in which they want to do things, and we would like to use these things. That's the purpose of libraries. If people have come up with a way of some interesting ways in which they want to control the memory or the computer, they will create what we call functions. And basically, once they create that, then it makes it very easy for everybody to use by simply writing the name of the function. And as you can probably notice, compared to everything else, is that they actually take this parentheses. And the parentheses basically is a way of indicating that most of the time, these functions, they will depend on some input, right? So for example, if I talk about the max, which maybe it will match your intuition, this is a function that will pick the maximum out of a set of numbers, right? So maximum and so on, it doesn't really make sense. But if you say the maximum of a set of numbers, then that makes sense, right? So that's why most of the functions, you can think of it as there are pieces of code that somehow will be conditioned, or they will depend on something that they have to manipulate, right? My function, minimum, sum, and so on. And again, similar to variables, they kind of abide by the same set of principles when it comes to naming them. Just keep in mind that whenever they are followed by brackets, that's usually a way to say that these are functions and not variables. And again, brackets have to be open and closed, like pretty much everything in regular math that you know. And everything that goes from the start to the end of the bracket will be considered to be taken as input to that function. So I think right now, in terms of time, this is pretty much what I wanted to cover using slides. But I think right now, in the interest of time, because we would also like to take a break around 6 o'clock to make sure that you get the chance to transition between different lectures. I would probably switch to the actual exercise set, unless there are some questions before we go in there.
What I'm going to do right now is I'm going to share with everyone a link, to Google Doc. This Google Doc will allow everyone to type in questions they have, and we will be monitoring it at the higher level. So the reason we do that is when we go down to the breakout rooms, you have the help. You can put up your hand, or you can type your questions into the document that I'm going to give you right now, and we can see it at the top level. And when we answer it, we will answer it here and or go into the room that you're in. So do put the room that you're in when you do that. Please continue.
Do we want to make sure that people are logged into Kaggle and they have access?
Yes. Does everybody have access to the Kaggle?
And probably a good time
use
to
use the yes and no to do that. Sorry.
Yeah, exactly. If you can use the icons, I think it'd be easier for us to see. But I somehow lost the icons on my side. So I see a bunch of yeses and no nos. Okay. So those who don't have access to Kaggle, please type no. It's fine. We'll walk you through it. But if everybody has access to Kaggle, this is good. Excellent. We have a no. Okay, so Sunny doesn't have access. So Sunny, you have to go to the link that Nabil just shared. And I think that's all you need to do. You don't need to register or anything else. But if you want to be certified at the end with Kaggle, so Kaggle will give you a certificate if you finish the course. It's good to sign in. But if you don't want to do it now, you can do it later. That's fine too. Nabil, Tony is saying he can't write. He got it. Okay. So it seems that we are fine with Kaggle.
So, if
so Nabil, what's the next step? Are you setting up the rooms?
So before we break out into the rooms, I just wanted to take maybe just a few minutes to basically just do it myself, a bit the process on the first piece of code, and then basically everybody else can actually follow through with that. So again, as I mentioned earlier, every lesson for the particular first lesson that we're looking right now, Hello Python, we have the tutorial and the exercises. So I'm not going to go to the tutorial because we talked about the slides and we spent some time doing the introduction, but the exercises, at least for It actually opens in a new tab, so I'll have to switch my presentation. The exercises themselves are much more, I would say, easier to follow even without having to go through the tutorial. But just keep in mind that you have access to the tutorial. So if ever you want to go back and walk through slowly through everything that is in the tutorial, or even look for answers within the tutorial, you should always go and look at it. Okay, so basically, whenever you see this page, this is the tutorial, and it talks a bit about, gives a bunch of examples. But at the bottom of every tutorial, you have a link to the programming exercise. And that's basically what I would like you to follow. And one way to know that you're actually within an exercise is the fact that you have these buttons here with run all, there's a power button and so on. Think of that as controlling your own virtual computer, because the way this works is you have your laptop, but really everything that you do within this exercise booklet or notepad is essentially working in something that is known as a virtual computer. So again, once you open this, the process is as follows. You go along and continue editing. Basically, there's a bunch of text that you can also change it, but essentially this was set up for you to read and follow through, and gives instructions on what is expected of you to do, and how you can actually follow through this whole session. But every time you see something that is kind of like a gray box, that's the piece that will be code. So that's essentially something that you want to go through, you want to modify, you want to play with, or most importantly, once you're done writing your code, you want to do this thing which is called execute cell, right? And the moment you execute the cell, for some reason is slow for me, and it's good that I'm running into issues because maybe you will also have this. The reason why it took a while for me to see the result was because the session itself, or my virtual computer, was still starting up. But now I see this green button, which means I have the green light and my computer is ready to listen to my commands. Yeah, so basically once I executed a cell, everything in the cell was executed one after another from top to bottom. It's always top to bottom. So the initial command that we got was spam amount is equal to 0. So, you know, referring back to my slides, spam amount, because it is something that sounds like English, but you have the underline and there's no quotes, which means it's a variable. This will point to a memory module. Then what follows after that is the equal, which is an operator. And what this operator does, it assigns a value to that particular piece of memory. So spam amount, the variable spam amount, which it will refer to that piece of memory, will be assigned 0, right? And that's the first command, okay? But of course, you don't get any visual feedback from that because I never asked for one. All it did, it changed the memory. Now we go to the second line, the second command, and now this looks very similar. Again, we start with spam amount is equal to spam amount plus 4 this time. So right now, we're not giving something that it's set in stone. Basically, right now, we're telling that I want this piece of memory to be replaced with something else. It started with 0, but I want it to be replaced with something else. So what does it get replaced with? Basically, the computer will take this and will interpret it as saying, I will try to look into the piece of memory that you mentioned as before as spam amount, and you want to store values. I will look whatever it's there, take the value that it's stored right there, add 4. And that will be the thing that gets assigned to spam amount, right? So doing some mental math, you will realize that what will happen is that now we will store in the same piece of memory a thing that the result of 0 plus 4, right? Whatever was stored before in spam amount plus 4, right? So this is 2 operations at a time. The plus to figure out what the new value of spam amount should be, and then the equal to assign it to that piece of memory now, okay? The third line of code is actually quite interesting, you know, and as the operator itself, if, that's the name of the operator here, kind of implies, it's saying that first it has to check, right, if something is true. If I'm trying to look at something and figure out whether it's true or false, in the case that that is true, the condition is true, I will do something. If it's false, then I will not, and I will skip exactly the set of instructions which were actually under this conditional, right? So that's basically how conditionals work. And the way you type conditionals is you start with the if, you follow through with the condition, And very, very important, you have to follow it with a colon, right? The moment you put the colon, that's when you're saying, I'm done describing the condition, and I will follow through telling you what should happen only when the condition is satisfied, okay? And that's basically the command that will follow. Another important thing, as you can see, all of the commands that are particular to that condition, that's true to be executed only when the condition is true, are shifted with a tab. So you don't, you're not shifting only top bottom, but if you shift from left to right, you know, on the horizontal, you will, that's an indication for the language that those things pertain to the if condition. If you forget to do the shift, then basically you will get an error that says, hey, you told me I should do something when a condition is true, or when a condition is true, but you didn't tell me what. So it's very, very important. I mean, you will get into this error. We will definitely help you through this and make sure that we change it in the right way. And what the command says is print and brackets. Remember what the brackets do after a name? It means this is a function. So what the function is the function, as the name implies, it will print something. And because we have the double quotes, it means that this is a full message. This is full English, and that's a constant that it's set in stone. And the message is, but I don't want any spam. And that's exactly what the function print will receive as input. And that's what the computer will print back as visual feedback. Okay? And the way to that is reflected is if you look at the output itself, you will see that that's exactly the first line that you see in the output. Okay? And then for the second line, I will try to explain this as well, and then we can break into separate rooms to kind of follow up with the tutorial. We have a new variable, right? Spam amount is one piece of memory that we've been working with up until now. Now we're saying, I want a new piece of memory. And this piece of memory from now on, I will refer to it as Viking_song. Okay, remember, it's not Viking space song, because that would be weird. The compiler or the computer would look at it and say, oh, I have two things. You need two memory slots, or whatever you're trying to do, I cannot understand. But in the case where you put the underscore, it's just saying that it's one token. It's one variable name that will be used for that piece of memory. And what do we do there? We do a new operation. At this time, it's not a plus anymore. It's a star, right? So the star is multiplication. So what the multiplication is between a constant, which is a string or a word in English, and we try to say, I want 4 times this piece of word, put it together. And that will be stored or associated with the variable name Viking song from now on, okay? And again, just assigning it doesn't do anything from a visual perspective. It is in the memory, but if I want to retrieve it and inspect to see the result, I definitely need to put this command here that says print brackets, because it's a function, and then we drop in between the brackets the name of the variable that we would like to inspect. And that's why we get the second line here that gets printed, which is spam, 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 which is spam times 4. Why 4? Because I was looking in the piece of memory that stores the value 4. And it's 4 because all of these other instructions were executed prior to the instruction that actually was trying to access that piece of memory. Okay? Last but not least, before you continue with the rest of the tutorial, make sure to always execute this one piece of code, which essentially is populating the memory with the solutions and with hints and other tools that you will be able to use to actually follow through with the tutorial in a much faster pace. So this is very important. If you don't run this, then sometime in the future, when you go lower and you try to execute other cells, you will get an error. And the error, it's usually telling you, I don't know what you're talking about. You're trying to get the solution or hint. It doesn't make sense. I never heard of anything like that. And that's equivalent to saying you did not add to your memory everything that is required to get the solutions. Okay? Just make sure you do that for every single tutorial that you're actually working on. All right, so
any questions at this point? Because this is important when you go into the rooms. This is really, you're going to be doing this. If you notice later on after 0, there's something called the Q0 check. The Q0 check is actually that code that it'll check for you. and there's a Q0 solution later on in the number 1, I think, or in the brackets underneath, to get to run it, or the Q hint, you have to remove the hashtag. That hashtag makes it a comment, or makes the line into a comment. If you remove the hashtag and then you run it, you can see what's going on, etc. So it'll execute that code as code. Use print. If you want to see what's going on, sometimes it makes sense to use extra print commands to see the values, etc. I apologize for this. Okay.
Yeah. So do we want to address just a few questions that were posted here before we break into other rooms? Yeah. So I think Shibl already addressed some questions related to the white spaces that we need for the if conditions. There's another question that says in the middle of a lane. I think in the middle of the lane, most of the times, it's fine to have more than just one space, as long as there is at least one. If there are some exceptions, and we'll run into them and address them as we go along. Yeah. Why can't we just write spam times 4? Why do we have to write spam times spam amount? That's a very good question. You can easily write spam times 4, but remember that what this means is that that command is set in stone. You will always use 4 no matter what. If you say spam times spam amount, then you could easily go and change some of the commands prior to that particular line that will change the spam amount in a different way. And then all of a sudden, spam times spam amount will print something completely different. So that's a different way of saying that I want my print to be dependent on something within the memory and not some set in stone value like 4, okay? And I think there was another question on the support doc. So the question is, why are true, false, and none constants and not variables? So again, just try to remind you the difference between constants and variables. Constants are things that are set in stone. They have a single meaning. They don't change over time, and they don't depend on some piece of memory that you can change, right? If they were variables, then true might mean something at one point, and then after I execute a few lines of code, all of a sudden they mean something else. So we don't want that. But we want true to always be true. We want false to be always false, because we want to use this as ways to determine different things within our code, and none pretty much the same. I didn't talk yet about none. When we get to that, hopefully we'll make more sense why it is a constant. But the principle is the same. Yeah. Okay. So does the Kaggle course expire, or we can complete it later? If you're signed in, all your progress is stored, so you don't lose anything. You know, if you have a partial solutions, you will once you come back and you sign in with the same credentials, then you will see your progress. If you don't sign in, then basically it's like a website. You refresh it and everything is lost. Okay. I think that was the last question that was asked. So maybe Mingzi can help us break people into separate rooms. And again, don't forget, you know, help each other, and we will definitely jump in and out to make sure that questions are addressed.
All right, well, we can start.
So just, you know, approximately how much time are you going to give people in the breakout rooms for the first exercise? Are we talking approximately 15 or 20 minutes? Just so people can know how much time to expect to be there.
So maybe let's do 20 minutes for now.
Okay.
And then we can have like a small break and people can do whatever they feel in those 10 minutes. Then we can come back and maybe talk a bit more about the second section.
Excellent. I think that makes a lot of sense. So good luck. What we'll do right now is we'll jump into the different rooms. You will be kind of sent there. You may have to press an acknowledgement on the screen to go into the room. Don't hesitate to do it. And we'll see you in the rooms. And I'll turn off the recording right now.
Before we continue, I wanted to see how many of you have an issue with something that has been raised in the document, and I also run into, which is this basically the kernel gets stuck and you can't. Maybe like in elementary, you would learn how to do integer division, where you would get the answer and then maybe the quotient, or the remainder. basically that's what a modulo b or a percentage b will do for you. Then I also mentioned this, a star star b. So if you have one star, you will have multiplication. If you do star star b, that would be the powering. So a star star 3 star star 2 is not 6. 3 star star 2 is actually 9, which is 3 times 3. And of course, the obvious negation, which again we kind of get from the stem intuition from regular mathematics. Yes, so let me see if there are any questions on this. It doesn't seem to have any, but feel free to also ask questions if you want in the chat in Zoom. But yeah, these are straightforward. It's always, but you also only have to be very, very aware of the distinction between integer division and regular division. Those two are quite, you know, sometimes even myself, I get that wrong. In terms of order of operations, I didn't really spend too much time on this because, again, the orders of operations, it's kind of kept to follow the rules that you learned in regular mathematics course. Again, if you try to brush up on those, right, there's ways to actually remember what the order is. Just keep in mind that that's basically, we try to follow the same order, with the exception that, you know, this idea of equal, which is the assignment, we don't really have that. I mean, we have it in mathematics, but it has a completely different meaning, right? Because in mathematics, we don't have this concept of memory that gets allocated different numbers or contents, but we do have that in Python. And because of that, we reserve it, and that's the last operation that we perform. So if you look at the presentation right now, and if you look at this line that assigns to total height in meters, it assigns hat height centimeters plus my height centimeters divided by 100, it will perform all the operations, and only when it's done with all the operations, it will do the equal, which is the assignment, right? So really, at the end, after everything is done, sorry about that, you compute everything, and then the final result is associated to total height in meters, right? So that's basically what's different from the order of operations in mathematics.
And
yeah.
one thing that I do is, if I forget the order, I just put parentheses everywhere I have any doubt. So you just add parentheses, then you don't need to remember anything.
Yes, exactly. So you're dealing with Python, not with a mathematics instructor who might be insulted or somehow take off points for that. Python doesn't care. If anything, it's happy because you make everything much, much more clear. And you make it clear for yourself when you read the code, right? But yeah, if you want to make sure you have no mistakes, you just do that and it will work perfectly. Yes, it's a great suggestion, Shibl. Yeah, and I did mention at some point this, we call them built-in functions. So built-in functions is just functions where you don't really have to define them yourself or try to figure out where do you go and get them. They come for free. Print is one of them. We've been using it. But there are others like minimum and maximum. So if you can see here, basically whenever I say minimum and I open the brackets because it's a function, everything within those brackets will be considered into this operation of computing the minimum, right? So in this case, you would say, what's the minimum of 1, 2, and 3, right? And the answer would be 1. And why do we do print afterwards? Why do we basically embrace all this with a print in additional set of brackets? It's because we want to know the answer. If we don't put the print, then yes, Python will compute the minimum of 1, 2, 3. It will know it's 1, but then it will throw away because it says, well, you don't care. You just want me to do some operations and throw it away. But the moment you say print, that gets sent back to you so you can see the answer, right? Min, then there's max, which does the exact opposite. It's very important. And then there's ABS. ABS stands for absolute value. So if you remember absolute value from mathematics, the principle is very simple. If the number is positive, it doesn't touch it. It returns the exact same thing. If the number is negative, it basically makes it positive. So it throws away the sign, right? So in both cases, absolute value of 32 and minus 32, they both have the same answer, which is 32. Okay, so just keep in mind that you have these operators there. We talked about types, right? And I talked about how you know, different numbers have different types. What's tricky, what's interesting about this is that you can also use this, the types, to use them as functions. And the way they operate is they take any input that you give them, and it says, I will convert that. I will treat it differently than you want me to, than it originally was. So if 10 had no decimal points, it was an integer before, the moment you give it as an input to the function float, essentially that converts it into 10.0, right? And that's why when you print it, you get 10.0 and not 10. And basically the flip side of that is that if you use int instead of float, so if you apply the function int on an input that is a float, like 3.33, then it will do its best to convert it to an integer. And in this case, it just returns the number, throwing away everything after the decimal, 3. And then even the more interesting one is, of course, remember that you have strings. So what's the difference between 807 without the quotes and 807 with the quotes? Well, remember that with the quotes, essentially that is treated as a sequence of characters. That could be text. You could have 807 with spaces and other words together. It's all fine. The moment we remove the quotes, it's an actual integer. But in this case, because we have the quotes, that is treated as a string. We call that a string, and it's a sequence of characters. We pass it to int, then it becomes a number. So once we do that, we can add 1. And once we add 1 to the integer version of 807 in quotes, then you will get 808. So I invite you, once you have a kernel that is actually working, to try to do the same by adding the string 807 plus 1 and see whether that works and what that gives. I can tell you, spoiler alert, it's not 808. So yeah, play around with these. The best way to learn about these things is once you see them in a tutorial or once you see them in an example, to actually go and play with it and try to change the numbers and the inputs and see what you get. But just keep that in mind, and that's basically what the exercises are intended to do as well. But of course, what I'm going to talk about in the next section is how to get help. And that basically provides a more structured way of actually understanding what things do. Because right now, these are simple things, and they kind of match pretty well the intuition, because these are concepts from mathematics. But there are many other functions which just have a single name, and it's very hard to even figure out what they do, unless you wrote it yourself or you try to get some help. But before we go even further, I think we have almost 25 minutes left. So I'll try to see if there's any questions on this first section. And if not, I'll probably switch to the other section. Any of the instructors have any other tricks that they want to share on operators and types? Okay, so there's one of you that would like me to talk a bit more about float and int. Yeah, so going back to what I was mentioning before, try to think of it more as, I mentioned about the operators, right? And what happens when we do different operations on numbers, right? And there is a distinction between numbers that are the integers, which basically is guaranteed to be either 0, 1, 2, 3, 4, 5. There's nothing in between, right? Or the natural numbers. So the moment that it's a natural number, that I know for sure that that piece of memory will only have those types of numbers and no decimal points, okay? A float, on the other hand, allows you to have decimal points. And sometimes, even if the number is, you can think of it as an integer, like 3.0, 3.00, they're all the same if you remember from mathematics. That's all equal to 3. But from the perspective of Python, it's a signal to say, you know what, I actually allow you to have in here, to store in this memory, things that have decimal points, whether you want it to have a decimal point there or not, right? You can treat them as functions as well. So in the last part of the presentation, I talked about this, the function version of it, right? And you can treat them as functions. And the way you treat them as function is to actually take whatever is given as input to that function. So let's say, for example, float, and the result is basically the float version of whatever you give it as an input, right? So if you give an input another float, then we'll just spit out the same thing, because it says, well, you give me a float, I'll just tell you that float. But if you give it an integer instead, or something else, it will do its best to come up with some float version of that. Right, so I invite you to try this out and see, like, oh, what happens if I do float on true, or float on false, or float on some list, or something like that. Once you get familiarize yourself with this concept, then maybe you'll understand a bit better why the best version, but the float version of anything actually even makes sense. But anyway, that's the purpose of that function. And again, on the flip side, the integer is the exact opposite, where you give it either an integer or float or something else, and it tries to make it as much as possible to fit it into this notion of 0, 1, 2, 3, 4, or the negative, of course. It includes negatives as well. Okay. Amar gave some very nice, I invite you all to look at the document with questions. Amar actually gave a very, very cute a set of exercises for you to try out once you have something that works, to actually learn a bit more about these converters and how to go from floats, ints, strings, and so on, and play around with the types. And again, probably if you do these exercises, that will cement a bit better this distinction between floats and ints, which it's not obvious. It takes a while to wrap your head around. So now let me just see if I can switch to the other section and talk a bit more about functions and how to use functions to get help. Okay. Yeah. So here's a nice instruction that we can send to our interpreter. Help brackets round. So it looks odd at first, right? You look at it and say, wait, there's a function, and I put brackets, and I throw in another function. The distinction between help and round here is that round is actually basically given as a parameter. It's given as an argument to help. So you're saying, I want help on the function round. I don't want to apply round. I don't want to execute round. I only want to know what round does. And that's why there's no brackets that follow round. But there are brackets that follow help, because I do want to apply the function help on round. I want to get help about round and not execute round. So the moment you do this, basically what you get back is it's a text that you can read. It's still a bit cryptic, because the more you use the function help, the more you will start to understand what every single detail in there actually means. But still, it should usually give you a good intuition of what it's supposed to do, right? So for example, here you would say, well, it rounds a number to a given precision in decimal digits, default 0 digits. This returns an int when called with one argument, otherwise the same type as a number, and digits may be negative. Okay, so again, maybe not everything makes sense here, and I invite you to actually go into more details in this tutorial. But basically, it does help a bit more than just, oh, there was one word that said round. So if anything, it kind of tells you, hey, actually, I could try to do rounding also on decimal numbers and try to get some decimal rounding. So for example, if I have 20 decimal points, maybe I only care about the first 2. So maybe this function helps. So then you try, because the text kind of implies that you can do that, and try to figure out either by Googling it or trying it yourself to see, how do you do that? How can I actually get different kind of precisions other than what I'm used to? Okay. Yeah, and basically the same applies to pretty much every function. So if you say help on print, it tells you how print works as well. And it tells you that there are some additional things that you can add to make print work differently. Again, we don't know how that works, but again, Googling it or trying it yourself helps quite a lot, okay? So whenever you work and whenever you have anything that you're stuck or you're not sure whether the function was used properly, always keep in mind that you can just write this one simple command that puts the function in between 2 brackets, apply help on it, and you should get at least some intuition of what that does. So now with that in mind, how do we write our own functions, right? Because all these things, if they're functions, is because somebody took their time to actually tell us exactly what are the specific commands that are actually associated with that function. So the way it's done, it's by using something very similar to if, but instead of if, we use def and not if, def for definition. So here we're saying we're going to define the following function. I'm going to give it a name. So def as a keyword, space, followed by the name that I want to give the function, then the brackets. But now what you put in the brackets, it's essentially what you would expect, right? What it works on. And here we don't go, we can only give variables because the constants don't make sense, right? When we say I want the least difference of 3 numbers, I'm not going to impose you and tell you exactly what the numbers are. If anything, I'm going to say these are something that whenever you call the function, you will tell me what those numbers are, right? If somebody would have defined print to take in, to work only on one string, that would have been kind of a bummer because then it would only print a single thing. But because we're allowed to give arguments, that function was defined to accept some kind of argument, some things that it will work on. And in this particular case, this list difference function works on 3 things. And we give them the names A, B, C, right? This makes them variables from the perspective of the function, okay? And similar to if, you definitely have to put the colon. As soon as you put the colon, that's the signal that everything that follows below, that is shifted with a tab or with a few spaces, will be part of the definition of the function, okay? All those instructions. So in this case, we have 4 instructions, okay? So keep in mind that every time anybody writes something like this, which you have below, right? List difference applied on 1, 10, and 100. What will happen is we will jump, the execution will jump straight to this function. It will change ABC to now have the values 1, 10, 100, and it will execute the next 4 lines that are part of the definition of the function. Okay, that's exactly how it works. So ABS I talked about. You should right now understand the first 3 lines. The one thing that, and mean as well, I talked about that, is this return. Okay, and the return is super, super important. If you forget it, things get executed, but you won't get back anything, right? Return is essentially saying, I want to give you back. I'm doing something, I'm doing a set of instructions, but I want to give you something in return, the result, right? In this particular case, we say, I'm going to promise to compute the least difference, so better tell me what the answer is. Don't just do some computations and change your memory and then forget about me. Tell me exactly what the answer is. And the moment I say return, min, blah, 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 it's the signal of saying the computation or everything that follows after return is actually going to be packaged and sent back to the place where we actually called this function. Okay, that's why when you get help, actually you will get something. Like when I say help print, the return is the packaged version of instructions of how to use this thing. Right? I cannot show you the implementation of help, but essentially that's what it would do. Right? So in the case of least difference, it will take the minimum of all these absolute differences, compute that minimum, and then return it back to the original place where the function is being called. Right? So that's an example of how you would use it. Right? I will compute the list difference in 3 different cases. The first case, I give 1, 10, 100. The second, I give 1, 10, 10. And the third case, I will give 5, 6, 7. Right? And in all these 3 cases, I will go back to the exact same place. The only difference would be that the ABCs will get different values, different times that I call this function, right? And of course, because ABC get different values, then the results will also be different. So in the first case, the result is 9 because the smallest difference is between 1 and 10. For the second one, the result is 0 because the smallest difference is between 10 and 10, and that's 0. And in the third case, the result is 1 because the smallest difference is between 5 and 6, right? And that's the answer 1. Okay. So I think since there's only 10 minutes left, I'll actually reserve that time so that everybody can ask questions that are more general, not specific to this. But feel free to ask questions even about this if there's time. And also to reach out to us. I think we will create a way for you to actually reach out to us. If you try to do the exercises in this section and the previous section, then we should be able to actually help you and step you through stuff if you get stuck. Maybe next time we'll reserve some time to actually, given the fact that we didn't have the time today to help you with the tutorial, maybe next time we'll start and maybe reserve 10 or 15 minutes just to answer questions related to these tutorials. But yeah, feel free to ask more. I thank you, Amar. I see that you actually addressed a lot of the questions that were asked as I was talking.
You're welcome. As it's an interesting question that someone posted, that can you already define a defined function? And that's essentially a step going ahead of what we were looking at this. So that's actually true. You can define a function which is already defined, and it's called function overloading. And you study about that in more detail once you do a compiler research. And as I said in the chat, like the compiler has a set of rules defined. So for any function that you call or write, it always checks locally that whether you have defined the function or not. If the compiler doesn't find anything, it tries to search in an inbuilt library. So it's like there are a set of rules. So feel free to ask any crazy question, and you might encounter that those questions actually are the core of some of the languages. So that's a good question.
So Mingxi, you suggested we put this question time. Do you have any questions yourself?
Yeah, sure. What is the main challenge learning to code for when you were starting out? What was the hardest part about it for you? Anyone want to answer?
Yeah, I can answer. I mean, I think the hardest part was getting organized, and it took me a long time to get the habits of being organized. And when you work at places like Google, I think a lot of the early days that you spend at Google, you do something called code review. So whenever you write code, before it's actually being used anywhere, it is sent to somebody else who will look at your code and will review it and will give you corrections. So the first time I wrote code at Google, it came back and forth probably 10 or 20 times. And every time I would fix something, they would find something else. And I was corrected on the smallest thing, like, for example, the position of the comma, if there is a point at the end of the line. And the objective of all of these exercises is to teach you how to organize your code so that you and others, when they come to them later, they can read them very easily. So it's very important when you learn how to code. There's initially the question of coding correctly, but then there's the second level, which is the element of style. So your code should be beautiful to read, easy to understand, readable for you, and readable for others.
Oh, very good. Gheorghe and Marty, you guys want to add anything?
Yeah, that everything that Shibl said resonates a lot with my experience as well. Maybe I'll go a bit more in when I started learning coding in university, and one of the things that I actually had to go and being organized as part of this was that I had my mind was trying to force somehow a mental model where I would want the computer to do what I thought it should do, as opposed to taking the time to understand exactly what the language actually, how the language interprets my commands. So I had this struggle where I was like, why doesn't it do what I want it to do? And I would try to fix exactly that one thing that I wrote to get it to do what I wanted to do, as opposed to actually taking the time, and pretty much the way that we showed right now, to go through help, try to talk to other people, and even Google exactly what specifically everything is supposed to do. So instead of ending up with an answer that is hard to read, I mean, even if it works, hard to read, and somehow it's just like an incremental, the result of incremental changes of my frustration that it doesn't work the way I intended to. It's much better to take a step back and try to understand exactly how to write something that is easy to read, and it definitely follows what the intents of the people that wrote the language at the moment when they designed it, because these are very smart people that actually took the time to think through it. So it's kind of like, it's important to respect that. So it's just kind of a small advice to people when they learn coding.
So if anybody want to ask any questions at all to our instructors, this is your time. Feel free to do anything. If you want to ask your question through the Zoom chat, that is also welcome.
So even ask if the progress in the lessons would be there tomorrow. I think if you logged in, it would be stored. If you didn't log in, as Gheorghe said, it would not. So I highly recommend you build an account, because at the end, you can see your progress, you get the certificate and so on. I mean, the certificate obviously is a computer certificate, so I'm not sure what value it has, but at least it gives you satisfaction that you finished the course. Tony is asking what to do to learn after the basic Python. So I don't know, Amar or Gheorghe, if you want to answer.
Yeah, that's a very difficult one. Like saying once you learn the basic stuff, I think we all are still in the phase of learning. So even after you learn a lot of Python, you will still see that there are always tips and tricks to do multiple things, like very few slicing techniques. That's just one way of handling things, but it's difficult to learn a language totally on its own. And I think Shibl or Gheorghe, you can share your experience, but that's my personal opinion.
I think you should try to think of other stuff that somehow requires programming skills, or at least basic programming skills, and that you're interested in, right? Like if you're interested in artificial intelligence, maybe there are some mathematical concepts that are too advanced to kind of start learning that for now. And that would tell you, like whenever you start an artificial intelligence course, they'll say, oh, maybe it's good to actually understand probabilities and linear algebra. And if you don't know that, then still try to figure out whether there's something where you can use your programming skills, the basics, into a topic that motivates you. Computer graphics or computer vision or anything that it's super interesting, or even web development, and try to see how can I use now my Python skills to do better web development or something like that. So try to push towards something that motivates you, and a topic that you like, and then that forces you to learn more Python. That's for sure. Like as Amar was saying, you're not done here. You're always learn Python, but at least it's in the context that motivates you and that keeps you, pushes you to learn Python for things that are super interesting for you.
I mean, I agree with Gheorghe, is that basically, once you learn the basics, I don't think you should continue to learn the language as such. What you should do is to try to do things. And as you do them, you learn what you need to get these things done. So for example, you can build a computer game. If you have a problem that you're trying to solve, like it could be a puzzle or something like that, you can try to code it and see if you can solve it. Something I learned recently, which I found very exciting, is that you can code Minecraft universes using Python. So there's an extension to Minecraft that allows you to actually guide the agents, build the worlds, do many, many, many exciting things. So if you like Minecraft, this would be, I think, a nice place to play. But basically, think about something you like and try to code it. Like that would be, I think, the next thing. Once you do a bit of these things, what you could do is you can join open source projects of people doing something, and then you can collaborate with them. And that gives you a lot of experience about working with teams, and then you learn from them what they know, and then you teach them as well. So it becomes a shared learning experience. Natalie had a question, is what to do for next course. So I think ideally, if you are able to complete the exercises for module 1 and module 2, that would be really good. If you cannot finish them, that's fine as well, because I think you can still follow the next class if you don't finish them, but I highly recommend you finish them.
Just before we move on to more questions, we actually have a feedback form we want everyone to complete, if you could, just to give us some feedback on what we should do better, so we can give you a better learning experience for the next 2 classes. So the forms link is in the Zoom chat. Everybody could just click on it and fill out the form. It takes about 1 minute. And then if not, we can continue with the questions. Thank you.
We can take one last question from Mark the Man, who's saying, is it better to know the basics in many languages or be advanced in only one? And Amar, I know you answered. So Gheorghe, I don't know if you have any thoughts on this.
I think basically similar to my other answer, advanced in the language, it's much better if you get to that advanced level by practice and by practicing something that you like. And the definition of advanced will be tied to what the specific topic that you want. So don't try to just get advanced just for the purpose of getting advanced. It's always good to tie it with something that you really are passionate about. And sometimes, you know, there's something that you're passionate about, and you figure out that they all tell you should learn another language because that's a lot more useful for that particular field. And that's when you know that it's better to actually learn a second language. It's not as if Python it's a waste of time because many of the concepts are very, very similar. So once you learn the first one, the second one will just be like, you know, the basics will be very, very quick.
But at the same time, I think if you have a choice, learning one language is better because it's more comfortable. You end up spending less time looking up documentation and so on. So if you can do a task in a language that you know, I think it's much better than learning a new language just for the sake of learning a new language.
It's also that once you have reached a certain level in any given programming language, you will find that almost all the high-level languages, they have a similar pattern and they all follow certain general techniques. So it's just like you master one of them and others, it's easy to pick up because you remember the path that you took to learn this one.
So it's past 7. Technically, you could leave right now if you want. The course has ended. But please fill out the feedback forms, preferably before next class. So, you know, that really give us insights on how we can improve. And if you have some more questions, obviously you could ask our instructors right now if you want. So we still have a little bit more time.
And final thing is that we're going to create a Slack channel and share it with you. So please feel free to go there. I suggest that you ask questions there and help each other. If you know the answer, help the people who need help. And obviously we will come in as well if more help is needed. But the best is for you to learn how to help each other through this. And thanks a lot for everybody. I'm going to leave now, but obviously people who want to stay can stay. Thanks a lot.
Okay, so the last time we ended the class, it was on functions, and I guess you had sufficient time to practice with it. The topic that we'll be doing with today are Booleans and conditionals. So conditionals are an important part of programming. These are mainly stuff like, if this happens, I should perform this specific task, or if this does not happen, I should perform this specific task. And executing a conditional, it takes two categories. So if this happens, that condition that if something will happen, if it's true or if it's false, what is going to happen? So the two important things are this true and false, and that's defined by the Boolean. So Boolean is also a data type which is already defined in the Python. So if I quickly do a recap, what are the other data types that you saw during the last class? Those were integers and floats. Those were also predefined data types. Even Boolean is a predefined data type. So if you type x is equal to true and you do a print of x, this just prints the value of x, which is true being stored. So now you see still this guy x, it's still a variable, but it's not holding anything like x is equal to 5. And you have to be careful about this guy, which is a single equal to. In mathematics, it has an assignment thing. So it defines an equation, but here it's an assignment operator. So operators are something that allows you to execute certain values. So doing an assignment assigns the value of true inside x, and the next line just prints it. And since you know what a type does, it refers to as type x, and that means it's desiring to know what is the specific type of x. But you should also pay attention to this guy, class. It's not simply a Boolean. It's a class which is defined under Boolean. So classes are something which have a set of rules of its own. So imagine something like So let's say you have your car and you have the wheels that drive. So everything that comes under drive, all those things have a specific task, but other than driving, cars are able to perform other tasks as well, like they can play audio. So those things can come under infotainment. So if I define my class car, there can be things like infotainment. Sorry, no R. There can be things that is related to drive. There can be things that is related to interior, which is the design and specifics. There can be things which is related to comfort and so on. But let's just focus on 4 of special stuff. So if I look at infotainment, what does that include? So that includes your stereo systems and other different things. And why this is of importance to us, because we should understand how is this, if I define my class, these guys can be my functions, and there will be all these functions can perform specific tasks. In a similar way, if I define my Boolean, that's defined under a specific data type, and that's encapsulated by this class operator, which is class variable, which is also inbuilt in Python library itself. So later on, when you go to an advanced stage, you will see how to modify or how to build these classes of your own. So this is just for your understanding, like what does a class do? So it's like a wrapper. So it wraps all the specifics of a data type within itself. So the comparison operators are these 3. There can be other ones as well, which is defined here. So these 6 comparison operators helps you to define a specific condition. The first one is A equals to B. So this does not mean A is equal to B. So doing this, A is equal to B, it means that the value of B should be stored in A. However, writing A equals to B, this means that the compiler is ordered that go and check whether value of A is equal to B or not. So this is a conditional and this is an assignment, and that's the key difference that you should know. So this guy is an assignment operator and that's a conditional. So going ahead, A is less than B. So that's just like your mathematical operation. A is less than equal to B, A is not equal to B, A is greater than B, and A is greater than equal to B. So a different combination of all these things. So for all these specific questions, the answer can either be yes or no. So for example, you can look here that a function definition given by def, and that's the function name, and that's the variable being passed inside a function. So now you should also be able to know the syntax in which Python accepts a function. So the syntax is given by def, your function name, and this guy is also optional. It's not necessary, but function name should definitely be there. And what this function does is, can someone of the given age run for president in US? And US Constitution says that the president should at least be 35 years old, which means that you need a conditional operator to check age of all the persons that are coming to you. So basically you are checking if age is greater than equal to 35. And notice that this conditional operator is attached with the return statement. So what this guy returns is a Boolean value. So this will return either true or false. And that true or false is being returned by the function itself. So this single line encompasses of a set of statements that will be executed behind it. So if you do print, can a 19-year-old run for president, and call the function again, can run for president 19, what this will do is it will pass this value 19 to the age, and from age it will go to this conditional, and using this conditional it will return back the value, and that's obviously the value is false. So drawing the path again, how this function is executed is starts from here to here, age goes from here, the comparison happens and it's returned to the function. From there, it's returned back to the print statement. So that's the way the execution is happening. Now, this is a very real example in the third step that you see. it's written 3.0 equals to 3. As I just explained, this equals to operator checks whether 3.0 equals to 3 or not. In some other programming languages, if you try to do this, it will return false. And that's because if you remember the data types that we learned during the last session, 3.0, what's the data type? If you remember, can someone reply in chat quickly? Exactly, that's float. And what's the data type of 3? That's an integer, right? So you are trying to compare float to an integer, and that's the beauty of Python. It's comparing the content. It is not just comparing the class. And why is that an important thing to us? Because if I write a is equal to hello and b is equal to hello, and if I do a is equal to b, is that true or false? Can people reply? In the context of Python. That's true. It's in the context of Python, it's true, but in the context of other language, for example, Java, this is a false statement. And that happens because of the way memories are allocated in a specific language. So this is an important thing to know, that even though you're comparing float to an integer, Python being a smart language, or say a good language, it looks at the content and ignores the decimal point and still returns a true value. So in the example which I picked up here, the answer is true in the context of Python, because it's looking also at the content. It just not looks at the memory spaces. And why I'm talking about memory space, because again, as me and Shibl, we discussed during the beginning of the class, whatever you store or whatever you write, that's being read by a compiler, which is a rule book, and that compiler translates it into a machine language. So all those variables, these guys, they occupy a specific memory location in computer's address, and those memory locations are the ones that are being compared. So this guy, it goes to that specific location to check what is stored in that location. So you need to be careful regarding what you're checking. So now, as it says, but sometimes that can be tricky. And why is that? So now you are comparing 3 equals to 3. So what's happening now that it's returning false? Why is it not looking at the content? So if I look at the data type, this data type is string, and this data type is int. And why is it returning false? Any guesses? Any takers? Okay, I guess none, or this might slow me down a bit. So that's because of the fact that string data types, because strings have no values. What does that mean? If I write a is equal to hello, strings have values. Strings have values as strings. So that's because of the way Python wraps string class and the way Python wraps an integer class. So that's again a rule book, which is a rule of Python compiler. That's because string is totally different type of class. It does not handle with numbers. So looking at the content does not matter in this case, or that's the decision taken by the developers, that looking at the content does not matter in case of string, because sometimes string can be really, really long. I can write like an entire book in a single string and say that now compare this book to an integer, which doesn't make sense because that's adding extra pressure to the compiler. So it makes no sense to compare a string to a number. And the moment Python sees that it's a number, it automatically returns false while comparing it to a string. So you really need to understand what's happening behind these two statements, like why is the first one true and why is the second one false? Am I clear, or are there any questions? Perfect. So moving ahead now, so far, what have we learned? We have learned how to compare. We have learned how to define a variable. We have learned how to create a function. That's essentially covering almost all the basics. So now we should be building up things. So the first function you see is checking whether a number is even or odd, or whether. So what the function is doing, it's checking whether a function is odd. So again, using the format, and this will come several times. So eventually you don't even need to learn it, since you will go on with hands-on practice. What you will do is you will just remember the format eventually. So again, this is the function name, the variable being passed to the function. And now if you take n modulo 2, this guy is called modulus. So I don't know if it was covered in the last class. So what that does is it takes a reminder. So it performs a division, like a mathematical division we used to do in high school. And still we do it, not only in high school. So that performs a division and checks whether the remainder is 1 or not. So again, performing this operation specifies that n has to be an integer. The moment you try to pass a string, this will throw an error, because this modulo operation is only defined for numbers. So there are a lot of implicit rules which are happening before even you write these codes. Like it is smartly able to detect what data types you are trying to use, like in other programming languages. And why I'm always comparing with other programming languages, in a way I'm selling somehow that Python is a better language than others, especially in terms of dealing with analytics and these kinds of operations. So when you do a modulo 2, so odd numbers, if you try to divide them by 2, there is always a reminder 1. So this, I can give even any other logic. So n modulo 2 not equal to 0, even that will return an, even that's the correct condition for checking whether a number is odd or not. So it totally depends upon the programmer what kind of logic you are trying to use. So for a similar type of problem, there can be multiple ways to approach the same thing. So even this logic will work here. So going ahead, this is straightforward.
I think this is something very important. Yeah.
Nabil, do you want to say something?
This is something very important to highlight. Yeah, I'm. Do you?
Yes,
sorry,
we can
I'm not
hear
sure.
you. We can hear you.
Yeah. Okay. So yeah. So this is very important to say. I think you know, Amar is trying ways, and trying to say it in many different ways. There's many solutions to the same question. Like your logic, there's different in a simple way, more complicated way.
Nabil, we can't hear you. Sorry, Nabil, your audio is not working
well. I think
now
we
we
are
can hear you.
losing.
Nabil, if you want, type it and we'll read it back.
Okay. So I guess just by looking at few of his audio clips, what Nabil wanted to say was the stressing on the fact that in order to approach the same problem, there are different ways, and you shouldn't be bothered that someone has taken one single approach and you cannot. So moving ahead, calling the same function again, is odd of 100. 100 is being passed to n, modulo happens, comparison happens, and the function returns the value back to this function, and a Boolean value is returned. So that's straightforward. Now combining different Boolean values. So what is being happened is, so far we were passing only a single parameter to a function. So if you look at this specific function, this guy has two different parameters, which is age and is naturally born US citizen. So again, the data types are not defined. So far the function is confused. It's ready to accept any data type for age and is naturally born citizen. So your return value is natural born citizen and age greater than equal to 25. So what this is doing is it's taking both these conditional operators and combining with the operator and. So if you guys are familiar how and works, so given two conditions, X and Y, and there should be a result as well. So if X, which is my first condition, if I'm trying to operate X and Y, So 0 means false, 1 means true. So if my X is false and 1 is true, then my result will be returned as false. But if my X is true and Y is false, this is still a false. And if both guys are true, then it's a true. If both are false, then it's a false. And what this is called is a truth table. So that's a truth table for your AND operator. And this is readily available, like this you might have studied in logics as well in high school, that how does an operator work. If not, just type on the chat, I can write it straight ahead, like a truth table for AND OR. So what this will happen is this function will return true only when if is natural born citizen is true, as well as the second condition is also true. So which means this will return true only when both the conditions are given are true. So let's look at the functioning. So 19 and true. So if this guy is true, then it's going to check for another condition that if age greater than equals to 35. So if that's true, but in this case, this is false. So this guy will return false. 55 and false. So false. So he's not a naturally born citizen, and also the age is greater. So this guy will also return false. In last case, it's true. So let me just ask you a question, that writing a statement this way versus if I write age greater than equal to 35 and is natural born citizen, which way to prefer? So let's call it method 1, let's call this method 2, and both methods are correct. So which method I would prefer in this specific logical operation, and why? Any takers or responders? Like based on the logic that you have learned so far, why would I prefer one method over the other? Like why to do it? Morgan, that's not correct. It's not because it's easier to read. There is a logic, and it does matter, Queen. It's not that it shouldn't matter. So maybe it's a bit tough question, but let me tell the answer. So the way AND works is that if you remember the truth table, if it is X is false and Y is false, this guy returns false. If X is true and Y is false, this guy returns false. And if both are false, this guy returns false. If one is true, then this guy returns true. So what happens is when it tries to look at the first condition, if the first condition is false, it just does not even tries to look at the second one. So if the person is not a naturally born citizen, it will ignore the second condition and return false straightforward. That's like saving time, saving additional time that you might have spent comparing this operation. And this comes by the virtue of looking at the problem itself. So you cannot be president of United States unless you are a natural citizen of United States. And that for this specific problem is a small task, but when your tasks get complicated, you might want your processes to be fast. So the first process in this case is faster compared to the second process, although both will have similar impact. But at a programming level, once you are trying to acquire good programming habits, these two are different in terms of speed of operations. That reason might sound simple, but trust me, once you start building up on Python, that reason is the reason for your faster speed. So in this case, yes, naturally born is binary, but it's like if naturally born is false, I don't need to look at the second condition. So if my first condition flops, the second condition doesn't matter. And in this case, naturally born is itself a binary number, and it's easy to look at a binary number. However, in second case, if I place this guy over here, it's not binary, it has to do a comparison. And that means it has to spend some time doing that. That means it will take a higher amount of time compared to the second operation, which is just a binary. So in order to know whether this guy is 0 or 1, computer has to do some work. However, in this case, this is already 0 or 1. So computer has to do almost nothing work to perform an operation. So you get the difference, like why one method is preferred over the other, although both will return almost exactly same result. So that's an additional knowledge or developing good programming habits in case of Python. So now you look at an operator OR. So even there is a truth table for X or Y. So if this guy is 0, this guy is 1, your result is 1. If this guy is 1, this guy is 0, the result is 1. If both are 1, the result is 1. If both are 0, then only in this case, this guy is 0. So that logic, it only works in case of AND operators. Other operators have other logics behind them. Nabil, do you want to say something? Okay, I think he's...
I'll mute him. I think he's just talking to somebody else.
Okay, so be better to put age in the second of def. So in this case, Morgan, it doesn't matter whether you put it first or second, because that's a comparison that's going to happen. So that's like just like a function check. So it doesn't matter where you put it first or second. So what she's referring to is, can I put this guy before age? And it doesn't matter, because by function definition, so no operation is being performed in the first line when it reads the function header. Since no operation is being performed, it doesn't matter wherever you put it. So again, based on the truth table or the logics that I've given, you can go through these variables and it's very straightforward. It's just developing more complicated logics. So if I do 0 or 1, the answer should be 1. But if I do, sorry, just give me a sec. If I do 0 or 1, bracket and 1, so this guy will return me 1. Then here you already have 1. So 1 and 1, that's 1. So basically this is like a reduction level programming where you try to do a comparison. So if you look at this, here there is a comparison happening with and this guy will look at this specific to or not, another logic. So you can keep on playing based on the truth table, which I just wrote. And what this not means is just negation of that. So if the value was supposed to be true, it will just flip it and return false. So any questions until Boolean operations before we move to conditionals? Let me just check the page for. Can you explain the meaning of the return button in a function? So what a return button, it's not a button, first of all, it's a command. So return command, what that does is whenever compiler encounters a return, that means that's the end of function. So whatever you're passing with the return, it executes that specific statement and terminates the function. So whenever a return is encountered with whatever operation the function has performed so far, it keeps that function in the memory and terminates the function. Def, it's just like a function definition. So like someone is named Amar. So when I go for a job application, the application writes me as Mr. Amar. And that Mr. is just a norm that is being followed. So here, a function header follows a norm that def function name. So that's again defined in the rule book. Of course, you can still go on modifying the rule book as well, but that language won't be called Python anymore. You will have to come up with your own languages. But when you modify the rule book in a language which still uses a compiler of Python, that means that language is still Python. Although you might write functions in different way, that doesn't mean that you are coding in a different language that you developed. So in order to develop a new language, you not only need to write the rule book, but also to write a compiler function for yourself. And doing that takes a lot of time and effort. So it's not straightforward. Okay, so if there are any more questions, then maybe we can take it. Otherwise, let's move on to conditionals.
Amar, it might be a good idea to show an example of, like you have here, inspect, explain what how def is working, what is it doing?
Oh, sure. So let me just check if it's not loaded. So, just give me a second.
While you are doing this, I can probably explain more about def. So basically, you want to define functions, right? So def is short for define. And if you want to define a function, for example, square, which takes a number and returns you the square of that number, you would write something like def square, you would open the bracket, and then you put the variable name that you want to send to that function. So you put def open bracket x, you close the bracket, you put columns, and then you put a new line. Now everything you put after the new line here will be part of that function. And what you do is, that's very specific to Python, is you put spaces before. So anything under the def. So okay, so Amar, I will bring it back. You can continue now that you have this.
Sure. So yeah, so I think my screen should be visible. I'm writing in Google Colab, which is also another kernel that allows you to run Python programs. So I just defined a function which is called def my function. That's the name of my function. It's taking a variable x, and I'm modifying the variable. So what I'm doing is I'm modifying the variable x and storing that modified value in x itself. So the variable that came here and the variable x, although these two are looking alike, both looks like x, it's overloaded. So let's say if x was 3, 3 plus 2
Amar, I don't think we need to understand overloaded at this point, right? So I think you can write functions without knowing the meaning of this.
That's also true. So 3 plus 2, 5 happens inside this function, and it's being stored in a variable, which is also called x. So let's just call it y for time being. And if I return this variable y, what this does is it returns the value 5. So let me just execute that and write print the value after function call is. So my function of 3. So it writes the value of after function call is 5. So you can also do something which is a composite of these functions. So another interesting way would be my function of 3. So what this does is, you know that my function of 3 is 5, and doing again my function is like my function of 5. So this guy should return 7. Oh, that's my spelling error. That's not an error. So that returns the value 7. So what def did is that just defined the signature of a function. I hope that's clear. Why doesn't print function need return? So that's how, again, it's defined in the rule book. It does not read any return because that's how print functions are defined. It's just to print whatever is inside that function. So whenever you define a custom function, then you have to define a return value. And it's not necessary that you need to define a return value. Even I can write functions like this. So def my function 2 of x y this is equal to x plus 2. Even this is a valid function and it's correct. It depends upon your usage. It does not need to return always something. So how and why we'll use this function, we might discuss this later on, but even functions without return, those are correct functions. Those are not incorrect.
And you have to be careful that there's the function definition, which is what is inside def. So when you say def my function, you're defining the meaning of defining that function. You do this once. Once you define the function, you can use it many, many, many times, right? So
yes,
the function definition and the function usage are not the same thing. So you don't use return in the function usage. Use return in the function definition, because in the definition, you are saying this function is going to return something to me. And you define what that thing is. When you use it, you just call the function, and whatever is returned back to you. So when you're using print, you're not actually defining print, you're just using it. And print is it was defined by somebody else. So you're just using a function that pre-exists and you don't need return in that case.
okay. Thank you. So moving on to conditionals. So this is just like a set of statements that allows you to use Boolean values in a more effective manner and try to build up with more complicated logics. So here they're trying to define a function inspect, and this function inspect is to check whether a number is positive, negative, or 0. So the logic that they are using is based on these three keywords, which is if, elif, and else. So if is like, if this specific condition happens, then do a set of jobs. Otherwise, if that does not happen and some other condition happens, then you use elif. Otherwise, if nothing happens, then you use else. So here, if your variable x equals to 0, then you should print x is equal to 0. If your x is greater than 0, then you print x is positive. If else is less than 0, print x is negative. Else, print x is, I haven't seen anything like this before. So this is just like, if my first condition happens, do this. If my second condition happens, do this, and so on. And if all the given conditions are exhausted and none of the conditions are met, whatever is present in the end, that happens. So let's just try to play with this guy a bit and explore it further. So we'll just copy the function as it is. And so this code book will be available to you later on. So I executed the function. So if I write inspect of 4, this returns 4 is positive, which means that it checked the first condition, 0, it was not 0. Then it checked the second condition, is it greater than 0? Yes, it was greater than 0. So it printed that, and that's the end. So I guess there was someone who asked the question that why doesn't print function need return? So you see that even this function inspect, this does not need any return. It's already just printing whatever comes inside it. So it totally depends upon what kind of task you want to be done or what kind of task you need the function to perform. Can anyone tell me how do I print the last one? X is unlike anything I have ever seen. So what should I pass? So inspect what? So what I mean is, what should I pass here? Inspect of what should I pass so that last condition is, yeah, that's correct. If I do like this, what happened? So someone told a string, and if I try to enter a string, it fails. That's because the operations, something like this, are not defined for strings. So as I explained ahead, just previously, that they are not defined for strings. So it is difficult to get the last condition executed, something which is a number and goes through a comparator operator and still goes for the else. So that won't happen. So someone is suggesting a variable, so still a variable will be executed. So if I write a is equal to 5 and pass a, still it will say 5 is positive because it's looking at the value of the variable. And these are like really good suggestions. And you're also exploring and learning how assigning different values matter and how they're executed. So I'll leave it up to you to play with it and come up with innovative techniques to check which conditions you need to get executed. So the second one is also a conditional example. So you define a function f of x. So if x is greater than 0, only printed when x is positive, also printed when x is positive. And if these conditions does not happen, so what happens is these specific conditions happen only when x is greater than 0. And even if those conditions happen, this is definitely going to happen. So line number 3 will always be printed, and line number 1 and 2. So I mean that's 1, that's 2, and that's 3. So line number 1 and 2 are printed only when this condition is met, and line number 3 is printed always. So if you pass f is equal to 1, that means the first condition was true, which means it printed first, second, as well as third. However, if you pass f is equal to 0, f of 0, so 0 greater than 0, that's false. So nothing was printed in 1 and 2. However, third line always gets printed. So that's what happens there. And Boolean conversion, it's like converting one data type to another, but we know that Boolean only happens for zeros and ones. So you can convert ones and zeros to Boolean data type as well, depending upon, again, your usage. So if you type Boolean of 1, that means it's trying to return a value true. And if you type Boolean of 0, that means it's trying to return a value of false. However, if you try to look at string variables and you try to forcibly convert them to Boolean, what happens? So that again happens according to the rule book. So if you try to do a Boolean of something which is empty, it comes out to be false. And generally empty sequences are false, which is written in the comment over here. And here, all strings are treated as true except they are empty strings. So you write anything inside a string that's treated as true. So these are the rule books that you need to know. So essentially that's it. And you can go to your turn, and I'll divide the lobby, or I cannot divide, Shibl has to divide, who is the host, in a groups of maybe
how do I divide,
Amar? Sorry?
How do I divide?
So if you click at the bottom, there is an option for breakout rooms. And
okay.
So what I mean to say to the people that we'll just divide you in groups of 10, and you will be transferred to a room, and maybe you can just discuss among yourself that, is there anything that you learn new? It's just like a chat room where you sit and discuss over something. So anything that you want to know more. So we'll just be dividing you in groups of 10, and you should be getting a request to.
So you want me to do it?
You can give me the host. I can do it quickly.
Well, I created it. I can just click create, and then I'll make you host.
Okay. Okay. Perfect. So if everyone in the main room can join your breakout rooms, and Nabil, I'll just pause the recording here because there is nothing in the main room.
Name of everybody in the class. So there are many people in the class. So initially I answered no, that the variable can only contain one thing, but I was talking here about simple variables like the one we studied. So there is another construct called the list. So if you want to keep a list of things, you can use a list. And I think we are going to see this in future classes. So you don't need to worry about it now, but there is a solution, and it is using a list.
Did everyone come from the breakout room?
Possibly, yes, we were 43, I think.
Okay. Okay, perfect. So
Amar, probably you want to answer Natalie's question. She's asking.
So if we inserted a list in the function, what would be the solution? Okay, good question, but just wait for till we have the second session. Because in short, like these operations define how they cast to different variable types. So list, it's not a single variable, it's a contiguous memory space. So just hold on to this question. We'll be looking at it after the break. So apart from this, are there any other questions?
Is Natalie thinking about being able to get to the bottom of to the values that we never seen before?
Yeah, there are special operations which does the thing. So I'll be covering those in the list, and that will make it straightforward, clear. So yeah, that will be better. And it's good that you are thinking ahead, like how do I do this and how do I do that? And that's really important. That's the way you get to learn more. So if there are any questions or something interesting that you discussed with your mates during the breakout room session, I know it's short and we are restricted on time, so we have to keep it really short and like we are really crammed on time. So I apologize for that, but that's how it is for now. So if there is any other questions that you'd like to ask, feel free to do so and we can take them. And we'll just have a small break as well. So we'll resume at 6:20. So a 10 minutes break because we started a bit late and there was some technical issues. So if you have anything, just feel free to write on the chat, and once we resume after break, we'll cover them all. Or okay, let's get back to our schedule. So the next thing that we are going to learn about is the list itself. So far we have learned that a variable can store only a single value or another variable or anything that's only a single quantity. Do I have to put parentheses to y in the function? This guy? Oh no, that's even without parentheses, it's fine. It will still do the work, so that's not important. As we discussed last time, that parentheses just stresses the compiler that you need to look here first. So,
there is a place where you need the parentheses is when you are calling the function.
Yes, that's right. For sure. Thanks.
So if you are doing something like function 25, you need to put parentheses around 25.
Yeah, you cannot do function space 25. That will throw an error.
Yeah.
So list, these are special kinds of representation where a single variable, so in this case prime, holds all this value. So all these values, they are being referred as indices. So a single value which comprises of different data types of similar kind. So stressing on the fact that all these are integers in itself. they are not something like integers, strings, numbers. So they can be other different data types as well. But for now, we are considering on list of pure numbers. So list of integers. So if I try to run this, all these variables are stored in prime. And if I do print primes, you can see that it directly prints the list itself. However, if I want to access each element of the list, I can do print prime of 0. Sorry, it's primes.
By the way, Kamal, in Colab, you can omit the print at the last line.
Even so, you can write the first element is something like this, and it writes the first element is 0. So what's happening over here is it's creating a directory of, so the primes is being written as 2, 3, 5, 7. And all these variables, they have been given special indices according to, again, the rule book of Python. So this is given by 0, 1, 2, 3. So if you do primes of 0, that allows you to access the element on the 0th index of primes. So that's 2. If you do primes of maybe 1 or 2, it allows you to access the number on the second indices. So here, a single variable is allowed, or a single variable is capable of storing a different set of values. Nathaniel asked a question. This is not a software, as I said, it's a Google Colab. So if someone of you might be using Google Drive, it's another tool that Google allows you to use freely for just if you're using to display something in Python. If you're doing it for more advanced work, there's charges behind that, but for a simple programming, it's useful. So yes, you can try this outside Kaggle on this. So if you just search for Google Colab and if you have a Gmail ID. Okay, someone asked a really good question that what happens if I do primes of 4? So there is no memory that's being allocated to primes of 4. So essentially it will give an error. So list index out of range. That means there is no index at a 4. So yeah, that's a good one. So coming back to here. So here, that's the second example where all the planets are being listed as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So far we have been looking only at a single dimensional list, meaning that list only in one dimension. But all these elements, this in itself can be a list. So it's like a list of different lists. So something which is being shown over here. And also, you see that these numbers are not pure, like they're not only integers or they're not only strings, but it's a combination. So what are lists? It's a memory allocation that allows you to have different numbers as well as any different data type. So as in case of hands, there is a list which is a collection of different lists in which the first list itself is JQK 222 and then 6AK. So let's try to get this and run. So you see all the elements are stored. And now if I try to access the first element, and if I try to do hands, you see that it's returning a list. So you should be careful how you try to build this thing up. Also, it's not necessary that you need to have equally spaced list, what I mean is I can even have something like this. So J and Q, and then 222, 6AK. And even that's a valid set of list. So it's really flexible on how you use this. So you see that now, if I do, it only displays J and Q because the first list has only 2 elements. The second list will have 3, and the third list will have 6AK, which is again 3. So if I do 1 over here, it's 3 elements. So that's essentially it. Again, a list can contain mix of different type of variables. So it does not have to be restricted only to a single kind of variables. So that's there. And then we'll already learned very quickly about indexing because it's not something which is really fancy. It's just that you need to know, and you need to play a bit how to access these indices. So if we look over here, and if we just look at primes of 0, that refers to the first variable. You can even use negative numbers over here. So you can do primes of -1. So what -1 does is it looks at the list from the behind or the back side. So that's -1, -2, -3, -4. Someone just commented on. It looks like you're using 2 as a string. So in the variable hands, yes, I'm using 2 as a string, but in variable primes, I'm using 2 as an integer. So there are no quotes around it. And also, you know the tool, if you want to check the type, you can just hit type of primes of 0. So that's an integer. So here you access that element and you check what type of that element is. So far, whatever yes, you can mix types within a list. That's what I was referring to over here, that you can have numbers and strings as well. That's fine. So something as my list equals to 2, A, that's a valid list. Okay, you're welcome. So getting back to our problem. So you can index the list from the behind side as well as you can index from using positive indices. The next problem is slicing. So extracting a part of a string, that's called a slicing. So if we define our list as planets, so let's say if my list is defined something like this, and if I do planets of 2 to 5, it will return all the planets with indices 2 to 5. So 0, 1, 2. So at second indices, you have Earth, 3, 4, and ignore 5. So if I index them 0, 1, 2, 3, 4, 5, 6, 7, and if I give 2 to 3, that means it will return 2, 3, 4, and ignore what the fifth index is. So that's again by the rule. And this process of extracting a part of list based on certain condition, that's called slicing. So that's that. So you can slice specifying the first and the last position, so starting and the end position. Also, you can specify just the ending position. So it will extract all the thing which is present before that position. So if you do planets of everything from start till index 4, so it will copy everything 0, 1, 2, 3, 4. So up till 0 to 3, it will copy all the things. So it ignores the last indices. Similarly, you can also do something like planets of 4 till end. So starting from 4th index, which is Jupiter, it will go till the end. So Jupiter, Saturn, Uranus, Neptune. So these are different ways of slicing a list. So you can play with it. So there are ways of using only the first and the last, or ignoring the first and the last, capture everything. Yes, Morgan, you can do the same thing from right as well. So are there any doubts up till here? Like slicing or going through the list? So those were pretty simple, right? Okay, so the next thing is mutation, which is like changing elements of the list. So sometimes it's possible that you want to modify once you have declared a list. So here, if I do print planets again, it prints me this value. And let's say I want to add something like planets of 8 is equal to, let's add a new planet to the solar system, which is hello. So it says list assignment out of range. And why is that? Because there was no index 8 assigned to it. Like there is no memory already allocated to it. So it's unable to add or modify something. So if you do 6, something which is already present there, it can show you that hello is being added. Although hello is not a planet, don't think that I'm saying hello is a planet. It's just, I'm writing a random string to a list. So you see that lists can also be mutated, meaning that all the elements or some specific elements of a list can be changed. Similarly, they can be changed based on slicing level as well. So all the elements starting from 0 index up till 3, so excluding 3, all those elements can be modified. Also, this is remodifying their old names. So that's it. Now, there are some functions in which you need to perform some operations on the list, like knowing what's the length of a list, or try to iterate how many elements are in the list. So the first function is length, that returns the length of the list. So if I do length of planets, so that's 8. So if my list is very long and I want to know the last index, this is a really quick function that will allow me to know. So now I know that my indices run from 0 to 7. Also, there is a function called sorted. So if you do that, it sorts the list in alphabetical order if it's a collection of different lists. So sorted of planets. So that sorts it in alphabetical order. Let's see what sorted of primes does. So it sorts in an increasing order. So these are inbuilt functions that some of them are listed here. Eventually with time, you get to learn more of these functions. So there is a function called sum and there is a function called max. So if you do sum of all the primes, it sums whatever is present in the list. Similarly, if you do max of primes, it returns the maximum value. However, there is also a function called min. So that returns the minimum of it. So basically now you're trying to use number and a character. Okay, that's interesting. Let's try to see what it does. So let's call it my list. And let's call it 1A G3. Okay, and now someone suggested that let's try to use sorted on my list. And again, and that's why we learned the operator before. So this inherently, this sorted, it tries to compare one element with respect to others. So it's currently trying to compare 1 with an A. And we learned that before that comparator does not work on operations like this, because string is a different kind of class. However, integers, they are different kind of class. So here it doesn't make sense to look at those values. So essentially you cannot use those operations. So these functions, although they are there, they are applicable only to certain kind of functions. Similarly, not only sorted, I guess, even some of my list won't work. Yeah, because again, performing an addition on this type of list is not allowed. So there are interludes which are called something called as objects. So now we are diving deeper into some more functionalities that you might encounter within a coding environment. So let's just try to see if there are any questions so far, because these are slightly advanced version of things that we have learned. So if there are any questions, now would be a good time before we jump into something a bit more advanced. Are there anything in the FAQ section? Someone asked an interesting question that I was just curious to know. I can imagine a company like Google's having lines and lines of code every day. What happens when you want to find a particular section of the code? How do they not get lost? Shibl, you want to take that?
Sorry, Amar, I missed the question.
I'm showing it on the screen.
I can't read what. Can you read it for me?
Sure. So someone asked that a company like Google have millions of lines of code. So how do they don't get lost when someone wants to find a particular section of the code?
Yes. Okay, that's a very good question. So first, we have a search engine for the code, which is actually very good. So we can search all the code that exists at Google in the search engine and then find what we need. And secondly, most of us are working within one subsection of our projects. So we know very well our projects. So it becomes like it becomes much smaller than everything at Google. And you will face the same. So it's not only Google. So even you, once you become good programmers, you'll be working, for example, if you work on, you want to change something in Linux, you will find that it's very, 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 very large code base. And you will have to learn how to navigate through this big code base.
And someone asked a question, can I get more complicated list? For example, planets and their respective sizes, more like a table, I guess. So there is something called as dictionary. I'm not sure whether we'll be looking at them today or not. So yes, the simple answer is yes. And you can use like a dictionary, which enables you to capture more information within a list. So a list of dictionaries will enable you to do that.
And the other way you could do it, which is not as beautiful as a dictionary, is that you can have a list, for example, of the names. You call it planet names. And then you have another list, which is called planet sizes. And then you go planet name 0. This will give you the name of the first planet, and planet size 0 will give you the size of the first planet.
And the last question here was, what will happen if return is not written when defining a function? That was answered, I guess, a couple of minutes ago. So it's not necessary to write a return.
Yeah, I think since this came many times, there are two. I mean, a way you can think of a function that the function could do one of two things. It can either calculate something for you, or it can do something for you. So for example, if you create a function that makes a sound, you say beep. So you just call beep, And let's say you can give it beep, you can give it parameters, how long you want the beep. That would be a function. This function doesn't need to return anything to you because it's doing something for you. But if you have a function that is doing calculation, for example, square, and then you give it x and you want to return, like you want it to calculate something, then you want the result of this calculation to come back to you so that when you call the function, you can get the result and use it in the rest of your code. And this is where the return comes in. So the return is what the result of the calculation that you bring back to the person who called the function. So again, you don't need a return if you are doing something, but you do need a return if you are calculating something.
Thank you, Shibl. So are there any more queries left? I guess not. If there are, feel free. So let's go a bit ahead and try to look at some of the objects. So what these guys are. So far we learned that data types, they behave like classes. And in the beginning, as I told, that you have your card, you have different functions which can perform different actions. So whenever you define any of these numbers, they acquire all the properties of the class, and you can access these properties based upon your requirement. So for example, let's just copy this guy and try to explore what different properties can be seen. So you see that first, x is being assigned as a number, and we know that this number is an int. So if I do type of x, we know that it's an integer. But once we know that it's an integer, there are certain functions that you can access for an integer class, like imag. So this is imaginary part of an integer. So, and now I'll also show you that how do you know that what functions are available for what list. So if you do x.imag, it's trying to search for imaginary part of this number. And for a real number, there are no imaginary parts, so it's trying to return a value 0. However, if you define a complex number, so let's say 12 plus 3j, and you do c.imag, meaning return imaginary part of c, that's 3. And if you do type of c, now the data type is no longer an integer, it's a complex number. Also, you can do something like print of c dot real. So that's 12, because the real part of this number is 12. So it also depends upon your environment, like how, if there will be a question, how do I know that which functions to call and when to call? So when to call, that depends upon your purpose, but which functions to call, that depends on the editor or wherever you are writing this code. Like I'm writing this on a Google's environment, so most of the built-in functions are already suggested to me. So you see that if I type print c dot, it's already showing me what are the inbuilt functions that I can use. So however, if you are typing in a Linux-based system, like in a terminal, you won't get the suggestions. So basically you can do a simple Google search that what are the functions available for this specific data type. So if I search for Python complex numbers, it will basically return me to a class where it will show me different functions that can be called. So basically you need to look at the library function which is being defined by the, or you need to look at the rule book. And this is like, this might be getting too advanced for some people, so don't get stressed out. It's normal, and since we are following a defined path, you need to know that how do I know these functions and what is being represented. So in short, whenever you define a number, there are some functions which are inbuilt which you can call, and these functions are called as the inbuilt functions that is being called as by the object. So here x, that's the object of an integer class that's accessing some information. So we have something called a class. We have something called as an object that can access properties of this class via an object. So whenever I write x is equal to 12, although x is a variable, that's correct. But x is also an object of the class integer. And now this object has the power to access whatever is the properties of that specific class. So does that make sense, or am I confusing you? I need to ask that. So someone told that what does J represent? So if you remember your high school mathematics, you saw something called as complex numbers, right? So something like 3 plus 4i, where the imaginary part is 4 and the real part is 3. So in terms of Python, they have a, if I want to represent this complex number, I'll write 3 plus 4j. So that's a way of representing complex numbers. So I guess it's already 6:50. We'll cover a bit. Okay, we'll just cover a bit, and I'll leave the floor to open to questions and discussions. So similarly, when you have assigned a variable, that's a variable as well as an object of the class. So since that object has a property of accessing different functions or properties of the class itself. So there is another function which I can write as x.bitLength, and that returns the bit length of the specific variable. So in this case, it will return the bit length of 12, and that's 4. So here you can do, as we learned previously, help of x.bitLength. So this method returns the bits necessary to represent that specific variable. So in this case, it's like 6 bits. So this is more like, what is my memory requirement for storing certain kind of value? So let's say I try to do this. X is equal to 1. Sorry, only numbers. And I try to hit enter. It stores, but how long can this number go? There should be a limit, right? So if I keep on entering, sorry, no negative signs as well. And if I do type of x, it's still an integer. So how big can this number go? That depends on the size of the integer that's being allocated. So of course, if I keep the number small, the amount of memory that I will need will be less. So let's just try x.bitLength. So you see that I need almost 190 bits. However, if I do y is equal to a smaller number, and I do print y dot bit length. So you see, there is also something which is really silly. So now if I do y dot, it's not suggesting me anything. And that's because y is not loaded into computer's memory. So now you will have to write it by yourself. So now you see that only 22 bits are required to represent this number. So although both are integers, they need different memory. So this is more kind of getting into the details and nitty-gritties of storing a variable and how big a number can you store in a variable and all those things. So bit length is one function that allows you to know the memory that you are trying to store in a variable. So with that, let's pause here. And I'll leave list methods up to you, because now we'll be just looking at different methods and their functions. And there are innumerable methods. Like it's not possible to even cover all the methods related to list or all the method related to any other data type. So now it's more on your purpose, like what you want to do and how you want to do. So the first thing you need to know is logic. Second was the basics that we covered so far. And now you are at a position where you can do almost all the basic stuff, including some of the functionalities. So I'll leave it up to you for practice from here, and you can have a look. And from the next class, we can pick up from tuples. Can we assign variables as functions? Yes, you can. In fact, that's one of the cool way of writing programs, but so far we haven't jumped into the details. So let's just pause here and take questions or discussions that we might have. And sorry if I made it too heavy for you. So questions? Okay, so far these are just the library functions that you can look at yourself and you can try exploring. So tuples, they are another kind of data types that you can see in Python, where it's something similar to list, but the functionalities are different. So if you write something like, instead of using square brackets, if you write something in parentheses like 1, 2, 3, they are treated as a single quantity. So it's like a pair kind of thing that goes together hand in hand. So the way to define a tuple is 1, 2, and 3, and or you can write it as 1, 2, 3 without any brackets. That's like assigning multiple values to a single variable. So something like a, this is equal to 5, 7, 9. And if you try to do that, and if you try to look at the value of a, that's a tuple. It's not like a single variable being assigned to it. So now, if you try to ask a question that what's the difference between a tuple and a list? So tuples, they cannot be modified. So as we saw in the list, that if I do t of 0 equals to 100, it modifies it to 100. However, tuples, they cannot be modified. Like, so if you try to do that to a tuple, it will say it does not support that specific assignment. So here you have an example of a tuple where your x is written as 0.125, and if you transfer that to an integer ratio, it will generate a tuple. So that's like showing where to use this function. So if I write x is a is equal to 0.35, or let's say something simpler, and do 8.2 integer ratio, sorry, as integer ratio. So now you see that a is being represented as an integer ratio. So this is like where to use tuple. So sometimes that can be really useful in doing some calculations. And again, that depends on the problem set and the aim that you're trying to achieve. But there are another different categories of immutable lists. So they are different from lists, but they behave similar to lists. And now if you want to know the numerators and denominators, so a variable defining numerator comma denominator, and x dot integer, we know that it returns something as a tuple. So whatever this value returns, it's being saved. So numerator saves as 1 and denominator as 8. So those values can be redivided, and just to check that whatever value you get is the same what you assigned. Similarly, we have a classic way of swapping. Like last time we were learning that how to swap, and I remember Shibl explained that you have an empty container and you transfer something to an empty, from empty you can swap. So tuples are also one of the ways of swapping. So here you have a is equal to 1 and b equals to 0. So if you write a comma b equals to b comma a, it inherently swaps. And back of the end, like again in the compiler, it's using the same technique, but here it's a much faster way of doing the same process. So sometimes you learn preliminary processes and later on you build on those preliminary processes to do a more complex job. So that's an efficient way of swapping two numbers without using any third variable. So yeah, that's all for these exercises. And I would recommend that you can start the coding challenge and practice some of the exercises so that you are able to cover up a lot of ground. And also this is like a lot of information has been covered today. So try to assimilate that and let us know if there is any problem and we can deal in the last session.
Yeah, so I think like by now you really covered a lot of the very, very important aspects of programming. In a way, we still have the loops, all very complicated. So I think the course today was a lot of material. So I highly recommend that you take the time to do the exercises. We created a Slack channel. I know many of you joined it, but many of you have not joined it. So if you have any questions, go on Slack, try to do the exercises, ask questions on Slack, try to help each other as well on Slack. Don't always wait for us to answer. And I think it's very exciting that if we continue like this, we still have one course left. And after that, you will be able to write basic programs and to do simple things, actually simple and very, very complex things, because with the tools you have, you can write extremely complex things. Obviously, it just needs more training and more getting used to it. Any final questions before we call it off?
There's a question from Mark Deman asking, when should we use a tuple instead of a list?
So I can give you my personal answer, and then Amar can give you his answer. Never. So my simple answer is a tuple is something can be used. There are very few situations where it's useful. I think at the stage where you are, I would always use a list. Amar, I don't know if you have a different opinion or you want to explain exactly like more the technical reason why you might sometimes want to use it.
It again depends upon your purpose. Sometimes if you just want to store some value and print it, I think neither of them matter. Like you can use whatever you want. But I would go with the basic definition as I explained, that when you want to deal with values where you want to constantly keep changing the values within a similar memory location, like you say you have 8 elements and you want to keep changing the values of those 8 elements, you cannot do that using a tuple, because those objects again are immutable. So sometimes dealing with complex programming, you come up with situations where you want to store variable such that they don't change the values further. So we haven't looked into the details of the methods of calling. So far, we are just calling that min of X or min of a list or max of a list, but we haven't looked how those functions call occur, or if we make any changes in those function calls, what changes are reflected within the function. So there is something called as call by value and call by reference, where you call something by value and where you call something by their memory address instead of calling them by value. And that exactly decides when to use a list versus when to use a tuple. So in short, if you don't want to change it, use tuple. Why you will decide not to change something, that I will leave you to explore. Like I might get very technical, which might sound like, what is this? But in short, that's the correct answer.
I mean, as a beginner programmer, I highly recommend you understand the lists very, very well. The tuples are less important to understand because you can do everything you need to do with the list. If you want to keep it, you can copy the list and so on in case you don't want to modify the values. And they are much more, they give you much more flexibility. So if you want to learn one of the two, I would learn lists and use it until I'm really stuck somewhere. And then you will find that tuples could be useful in some rare situations.
Yeah. The key is to try and do examples and try different things. One thing I know, if you notice when Amar is working, he would type in the variable name just to see what will come out, or do a print statement. Those are ways to, when you're doing a function, to see what's going on. Like using a lot of print statements is not recommended for an advanced programmer, but for somebody who's starting, prints are a very nice way to see how things are progressing inside code. So you can see what's going on, you can see the progress of the code, and see all the values, so you can understand what's going on.
So someone asked me, like, what's the difference between a compiler and an interpreter? So that's a really good question. But again, like at a programming level, it really doesn't make a difference to you. But for the sake of answer, I'll tell you. So whenever you write any source code, a compiler translates it into a machine code, so something that machine would understand, and then displays a result. However, an interpreter, it skips that junction of translating anything to machine code. So it's not a translator. It just takes your source code, so whatever you have written, and tries to get an output without translating it to a machine code. So doing that will sound something to you like, why do I need to do that? Or why do I need to translate everything to machine code? That's because execution of machine codes are easier in sense of the logics that they require. So again, it's like going into the details of computer architecture, which again is not the scope of this course. So I'll stop there, but essentially that's the main difference.
Any last questions? No. So thank you. I'm going to say on behalf of, thanks Amar, thanks Shibl. Thank you all for being with us. This is complex, like this is not easy, but the key thing right now is to go through the exercises and come in the next session with more questions. Don't feel discouraged. It is not simple. And the whole idea is go back to the beginning and redo everything. You'll start finding by repetition and doing more examples that it's a lot easier over time.
Thanks.
Thank you all.
Thanks, everyone.
And for the Slack channel, join there, and we'll see.
All right. So I'm sharing now my screen with loops and lists, I think. Yes. Okay. So feel free to, for the host, feel free to just interrupt me vocally because I'm looking at the actual page and it might actually miss if there's questions or anything that is not clear. All right. So let's talk a bit about loops. Right. I talked about, as you can see here, this is kind of goes into the last question that we had there, where we have the colon, right? We have the colon, and after the colon, there's something that follows. So this is called a for loop. Instead of an if, now we have a for. So a for loop is basically very, very useful. And I think the best way to think about it is because you talked about lists. So lists is things that got put together, and there's a lot of interesting things that you can do with lists. But the most important thing about lists is that most of the time, when you have lists, these are things that kind of go together, which means that you will want to execute the same piece of code on every single element in the list. And because of that, you wouldn't want to, if I have 10 elements in the list, you wouldn't want to write 10 different lines of code for every single individual step. Instead, you would just want to write one piece of code and then make sure that the exact same thing is executed on every single element of the list, right? So that's kind of the simplest use case for a for loop. So as you can see here in this example, we have a number of planets, right? We have, is it 8 of them, right? We have 8 planets in the list, and we want to do something very simple. We just want to print the name of the planet in the list, right? But again, I'm not going to say print planets 0. You always start at 0 in computer science. Print planets 1, planets 2, planets 3, planets 4. What we're doing, we're just using the concept of a for loop to say, whatever you have in the list, however long it is, I don't care, just do the exact same thing on every element, right? So how do you do that? Again, you start with a for, you say for planet in planets, right? So planet is a new variable name. It's not something that already exists. Planets already exist, but planet is something that is a new variable name, right? And this is the variable name that you will use to reference any of the elements on which you're doing the operation, right? So planets is the full list. Planet is every individual element in your list, right? Again, you have to use the colon because what follows is an indented piece of code that will be executed for every single element in the list. And what we'll print there, we will say print planet. Again, we're not printing all the planets. What we're printing is the element itself. And the way in which we reference every single element is by using this new variable name called planet without an S, okay? And what's the end result is printed, all the elements printed on the exact same line. The reason they all get printed on the same line is this additional parameter for print, which I'm not sure if it was covered last time or not, but I can explain it today. If we remove this additional parameter that says and is equal to a space, then essentially by default, the printing would print the name of the planet and then go to the next line. So then if we wouldn't have this, basically you would have all the planets but printed on separate lines. But because we're saying the end is actually not a next line, we're not going to a next line when we print, but we're actually just going to put a space and continue printing, then essentially the end result is going to be all the elements in the list, but separated by white spaces. Okay, so this is kind of like the first example of using a for loop. And don't forget that there's always this in, right? If I say for planet and I forget the in, then you will get an error because the compiler will be very confused. Will say, what do you actually want me to do? But whenever we say for planet in planets, then it will know to actually go through the list and pick every element in the list, okay? And that's very important. Another error that you would get is if, for example, you would say for planet in something that is not a list. If you're trying to kind of go over things that are not a list, then the compiler will also say, I don't know what to do, right? I really expect you to give me a list here that I have to go over from beginning to end, right? So keep in mind, one, the for, the in, the colon, and the indentation. They're all very crucial things. In the beginning, you might forget one or the other. It takes a while to get used to it, but then it becomes second nature, as you will see as you keep on programming more and more, okay? So let's see another example. Hopefully this was a simple example and easy to understand, but let's try to see the exact same thing, but now we're doing something different, right? So now we have another list, and this is a multiplicand, right? And as the name might imply, what we would like to do is to take the product of everything in the list, right? So what is it that the one thing that we would like to do with every single element? Well, think of it as I would like to multiply it with some partial result, right? The partial result when we start multiplying things is 1. If we start with 0, then we say 0 times a number times another number. As you recall from your math classes, this will end up being 0. But if we start with 1 and we keep on multiplying things to this 1, we will basically end up with the product of the numbers, right? So we start with 1, and essentially what we do, we go over the list. This is basically Python for I'm going over the list of multiplicands, and I will use the word MULT to refer to the element that I'm processing at every time step, right? And how do we process the element? Well, we're saying the product, we start with 1, but as we go over the list, this basically starts accumulating all of these multiplicands, right? And you would say product is equal to whatever you had up until now, the partial product that you had up to this point, times the new element in the list, okay? And of course, the last line here, after you're done with the for, you print the end result, which if you do the multiplication yourself, you would get 360. One thing that was not there in the previous example, but it's super, super important, you will notice that the last line where I just want to print the final result is actually indented back, right? So it doesn't have the same indent as the actual multiplications that I do on every element of the list, right? And if I would have forgotten that to shift back the indent, essentially what would have happened, I would have printed the partial product at every iteration. So every time I would go over the elements, I would have first multiplied the number, then I would have printed the result. But what we want is not to do that at every time step. And because of that, we make sure that it's not in the indent. So it's not part of the for loop. This is after I'm done with the for loop. And the signal that I'm done with the for loop is once I finished indenting, right? And of course, the indent is triggered by this colon here, which says I'm starting the for loop.
Gheorghe, we have two questions.
Yes.
The first one is, why don't you need a return in this example?
Yes, it's a very good question. Usually the return is a keyword that is reserved for functions. So in this particular thing, you just have a number of lines of code where you just do the multiplication and then you print the result. If you would have wanted this to be a function that takes in a list of multiplicand and then it returns the result, then you would have had to use def, the name of the function, then the parameter, the variables, write all this code, then return the product. But you're not writing a function right now. You're just executing some code. Very good question.
So Gunter, probably to answer your question, probably when we get to an example that has a function, we'll go back and explain what return is. So return is only used when there are functions. And when we get to functions, we'll explain it in context. There's another question, Gheorghe, which is, how is it known that variable mult refers to each element of list multiplicants?
Okay. So maybe it would be good to, it's a very, very good that you asked this question. So what I will do, I will share a separate collab instead, and maybe I can just go one by one. So hopefully now you see a different one. So I just copy pasted the piece of code, and I will try to write in comments what will happen one by one, step by step. So we start with product is equal to 1, all right? And then whenever we execute the code, remember we execute this for every single element. So the first time we execute this line of code, what will happen, we will say mult is equal to, and we look into the list and we say, what's the first element? And the first element is 2, okay? So we do that. Then once we're done that, we're going to say product is equal to product times mult, right? Which means that product will be equal to 1 times 2, okay? Now, we continue because we're not done with the list. The list doesn't have just one element. The list has multiple elements, right? So now mult, we go and we say, what's the second element in the list? 2. Mult is equal to 2 now, right? The second element is not the first, it's the second one. And the product now is going to be the exact same thing because always the exact same sentence, right? But not the same result. Remember that. It's the same sentence, it's the same command that is being executed, but the results are different. Why? Because now product, because of the first execution of the command, it became 2, and I have to multiply with mult, which is now 2, okay? So I'm just going to copy paste this again because the third one ends up being the same thing, right? We have another 2, and so now we would have 4 times 2, and then by the third element, now mult becomes 3, and then the product will be 8 times 3 this time, right? And 8 being the result of the previous iteration times 2. So essentially, you keep on doing this until you're done with the list.
Something to think about, and when you're a beginner, you can add print statements just to see what's going on. So you may want to put in your for loop, you did this by hand, but you can put the same, print product and print, you can see what's going on at each point, and this might help them, might help you see it. Like this is something that's useful. Exactly. This is something that when you're a beginner, using print statements is very useful to help you. It's not it adds a lot on your screen, but you can see what happens. I'll turn it over to you. Sorry.
Yeah, that's a great suggestion. Yeah. Okay, so let me just go back to the loops comprehensions. Yeah. So it's all very, very good questions. But remember that this is the whole purpose of having something like this. Is basically getting a one variable name that will refer every single individual element. And how do we know it? It's because that's how the language was designed, so that you can easily write code that is very concise and not having to repeat the same thing over and over. like I had in the previous comments in my code. Yeah, so another interesting example, right? This is the way that we can do multiplication, is to process this string, right? It's a string, which is just a sequence of characters. You have a bunch of characters all put together. And this example is actually proving the concept of steganography, right? Where you're kind of concealing something hidden inside a much larger sentence. So in this case, basically all the capital letters are the hidden word. And you put this into a very large string where it makes it hard for you to actually see what the hidden word is. But how do we actually retrieve the hidden word, right? Basically, we want to extract all the characters that are capitalized, right? So similar to the way that we started here with a product of 1, and then we're slowly collected the product of every single number as we went along. We would do something similar. We would start with an empty string. So message is equal to quote, quote, right? That's equivalent to saying I have no characters, but I know that message is a string. And what I will do is I will go over every single character. So see how I use the English to describe that. But the way we would say that in Python is for a new variable name in a list, right? So for char in S. S is my list because a string is a list of characters, right? And what do we do there? What we're going to do, we will first check, right, whether or not that's a capital letter. Because we only want to keep the capital letters. If it's not a capital letters, I want to skip it, right? So this is where we would go with an if. So we put an if and then a sentence that evaluates to a Boolean, either true or false. And the way we can check if whether a character is uppercase or lowercase is by simply saying char dot is upper with the brackets, right? Why with the brackets? Because this is a function, right? We're calling a function that is trying to tell us whether or not this is an uppercase letter or not. Okay, and something that is very important to notice here is that much like the for loop, which takes a colon, the if condition also takes a colon. Again, why? Because we want to write now, we will write right after the colon, we will write a block of code that is only executed when the condition is true, right? I'm only going to print char if char is uppercase and not otherwise, right? And as you can see, I'm indenting even further the print statement because that's part of an if that's inside of for, right? And essentially this piece of code will go through the entire string and it will print only the capital letters. And what are the capital letters? H-E-L-L-O. Probably can do it yourself if you want to go over it, but that's basically what the code extracts out of that.
You get a question from Rico. He's asking, is char a special variable or can we put anything in there?
You can put anything in there. Now, I think this is the name that was chosen here, but it's not, whenever you write a for loop, you don't need to actually come up with, the only special words are for, is, if, and print. This is the only special words that you're seeing here. Everything else is chosen by whoever is using the code. Yeah.
For the colored words, right?
Yes. Yeah. Usually you will have them as colored as a way to kind of for them to stand out, to make sure that yes, that's indeed what I wanted to do. If things don't color out, that's when you should be like, oh, oops, am I doing it? I'm doing the right thing.
Nicholas asking an interesting question. He's saying, are all of these functions used in real jobs in programming, or is it just for beginners?
Every day. So for loops, conditionals, booleans, integers, floats, strings, all of these things, we definitely use it on the regular. It's basically kind of like the building blocks. It's like learning the alphabet when you're trying to learn how to read or to write. This is kind of the stuff that you will always see. It's just that when you learn the alphabet, if I show you A, B, C, D, E, F, might be boring in the beginning. But of course, once you put these letters together, the alphabet together, you start getting interesting stuff. But it's a very good question.
Interesting that for and if are probably the most common things you would use. And with for and if, you probably can do everything.
Yes.
Like everything in programming can be done with for and if. Then there was a question, so the comma would act for any scenario from Evan. So I don't know exactly what Evan means, but that's the question.
So the comma would act for any scenarios. Maybe it would be good to clarify the question even, because I'm not sure what you're referring to. Yeah.
And Mark Mann is asking a good question with the char that is upper does not require any arguments.
Yes, this is a very, very good question. So I don't want to go into the details of this, but try to think of this as sometimes normally you would just use is upper, and in the parentheses you would put char, and probably this is how you were used to up until now. But there are some special cases, and the details are not super important, where it's more readable to actually start and say char dot is upper, to put the name of the thing in which you operate and then the name of the function. It doesn't always work. So this is just to give you a bit of an incentive to read more about this. This is when you work with the classes and objects, but we're not going to cover that topic. So it's just think of it as an inverted case. This is really Google stuff and say, how do I check for upper and lower, and just do whatever people are doing. But just think of this as they're kind of equivalent. There's not a rule of thumb to do that. Yeah. Yeah, so Evan is saying the comma, so the comma would act for any scenarios comparing to the colon. So the comma is usually used to separate things in a list or to separate arguments to a function. Maybe there are other cases that I can think of, but this is basically where you would have the comma, right? To just say, first, second, third element in a particular list, and you put the commas in between. In this case, we have a comma to separate char and the second parameter, which says what the end would be once I finish printing the character. So in this case, I don't want to print anything because I want to attach all the letters together. The colon it's completely different scenario. The colon is reserved for ifs and fors, and we'll see very soon the while loop that was mentioned earlier today. Yeah. So that's the distinction between the two. Perfect. Wonderful. Okay. So range. Let's go to range. Range is a very interesting function. Range is just kind of like a nice way to come up with lists that are really useful, and they come up all over the place, and you just don't want to write it every time. Right. So for example, if I want to say, oh, I want to go over all the numbers between 0 and 5. Of course, one thing you can do is to use what you learned about lists and to say, okay, square bracket 0, 1, 2, 3, 4. And I'm done. I have all the numbers between 0 and 5. Usually when we say range, we don't include the last one, right? So a shorthand for that, instead of writing it every time, is to just say range. So the moment I say range brackets 5, that's the equivalent of saying the list 0, 1, 2, 3, 4, excluding 5. We don't include 5. Bam. If you want to go from 0 to 19, so range, you would just say range 20, and you're done, right? So it's just a wonderful way. It's a very useful way to be very concise about the things that you iterate over. But just remember that it's super, like range is also one of these other functions that on day-to-day jobs is very, very useful, and it comes up a lot of the times. Especially if you want to repeat the same things, but you don't necessarily care about the numbers, but you just care, I want to do something 20 times. If I want to do something 20 times, then I would just say for I in range 20, and then I'm guaranteed to repeat the same thing 20 times. Okay?
And one thing to remember is that in programming, we like to start counting with 0, which is we're not used to. In real life, we typically start counting with 1, but in programming, we start counting with 0. So this is why when you say range 5, you're getting 5 elements, but you start counting with 0, so you go from 0 to 4. And you don't. If you went from 0 to 5, you will get 6 elements. Yeah. So it's a bit counterintuitive in the beginning, but you have to get used to it because that's what most programming languages would do.
Yeah, thank you, Shibl. That's a great comment, and it's something that it becomes second nature. But until it becomes second nature, it's quite annoying. But again, as you always do when you code, you write something. You look what the results are, you investigate what could go wrong, and then in many cases you end up seeing, what I got wrong is that I thought that I'm starting at 1 with my counting, but it started at 0. And slowly you adjust.
Very, very good question from Ali Sharif. What if I say range 0?
Okay, let's try it. Let's try to see what happens when we do range 0. I'm going to present my other tab. All right, so let's do for I in range 0. Oops, nothing happened. So we can see why nothing happened, and we will investigate in a separate cell. And basically what we will do, we will just run this and see what do we get. So range 0, it prints this thing, which is kind of like, it has its own meaning, but usually it's an empty list. So if I convert it to a list, I don't know if this will work, but yes, if I convert it to a list, it will just say there's nothing. So it doesn't break. It doesn't do anything really particular either. But it will happen. So for example, as I mentioned, sometimes you just want to do things when you have things to work with. So you might say, user, please give me some things that you want me to think about or to process. The user doesn't give you anything. You can still write the code. It's just that the code won't do anything because it will just say range, nothing. I'm not going to do anything. Okay? It's a very good question. I always like that we call this corner cases, and it's one of the things that programmers always forget about, but it's super, super important in our day-to-day job to make sure that we cover this particular cases that, you know, they're not necessarily, they don't come first to your mind, but they're super important.
So Gunter has an even more difficult question, is what happens if you do range -1?
-1. Range -1, I think something similar will happen, where because it's a negative, it goes at 0 and it says, do I have anything between 0 and -1? And it doesn't know to actually go backwards. I think there's a way to actually go backwards. I forgot the actual way to do it, but you can actually Google and say, how can I range by doing backwards? Because maybe when you say range -4, you might think, oh, I'm just want to go from 0 to -1, -2, -3, and so on. But you should Google it and try to see how exactly you can use the function range to do exactly that. But in this case, as you can see, we still get an empty list. Yeah. Perfect. So let me go back to the other tabs with loops. Okay, so again, I invite you to look at the range. There's different ways to play with this. Like it goes from 0 to 5, but by counting by 1, there's ways to actually count by 2, by 5, by 10, whatever you want to do. There's very interesting things to do. It's a very nice exercise to learn a bit more about using range. But let me talk about while, because while was also mentioned earlier, right? Somebody asked about it. And while is a bit different because while is basically not saying I'm going to come up with a list and I'm going to process everything in the list. Instead, I'm just going to repeat something while there's a condition that is true, right? So similar to if, when I would say, if a condition is true, I will execute something. If only executes this one thing once, and that's it. Think of while similar to if, but while will repeat doing that thing as long as the condition is true, right? So in this case, I start with I is equal to 0, and I say, while that number I is less than 10, I will keep on doing two things, right? Both of them are indented. So remember, there's the colon, and then what follows is indented code. Two sentences are indented. Bam, both of them will be executed. So I start by printing the number I, and what I do is I do this plus equal. Plus equal is equivalent to increment. So I change the value, whatever it was before, I add 1 to it, right? So in this case, I start with 0, I print 0, then I add 1. Is it less than 10 still? It's still less than 10. So I'm going to keep on doing this until I get to 10. So because the code essentially prints all the numbers and then it increments it by 1. So it just goes 1 by 1, prints all of them until it gets to 10. And once it gets to 10, it says, oh, well, is 10 less than 10? No, 10 is not less than 10. As Shibl was showing examples before, this will evaluate to false. And then basically the while loop will say, I'm done. I've done this enough. I can get out and continue with my day or whatever else has to be done. Okay. This is an interesting way to go over things even without lists. So it's not just it's really something where you have a condition. You know, you can think of it as even if you have an exchange, I will wait for the user to give me the right word until I get the right word. And if we have the time today, we will go over some example of hangman, where we would use something like this, where we would say while The user has not solved the game. I'm going to keep on repeating and keep on doing the same thing until we get the word and we're done. We're happy. But hopefully we'll get the time to copy that. So now the last section, I think it's mostly on list comprehensions. We'll go quickly over that because it's really something that we call it syntactic sugar. It's just kind of like a pretty way of saying things that you could otherwise say using like a bunch of numbers, a bunch of lines of code. But it's good to know because you will see people doing this and maybe you would want to do it yourself. Why not? So list comprehensions, as it is explained, it's a way to explain, to create lists, but without having to write this fors and so on, with multiple lines. So for example, if I want to have a list of all the possible square numbers, right, I could give it as an exercise and say, hey, you've seen in the past how you can do interesting things with the for loop. Why don't you write some code for that? But I think it's good to keep in mind that you can do this very easily by just defining the list with a for inside of the list. So it's this interesting thing where I start a list and then I have a part that says for n in range 10. Now here we don't have the colon. The reason we don't have the colon is because we're not going to start describing a number of instructions that get executed for every single element in range 10. No, instead what I want to do is I want to take this list, take everything in the list and process it to build another list, right? So the way it works, again, you write the for n in range 10, similar to the for loop, but then instead of the colon, you explain the formula that will process the list itself. Okay, so in this case, what I'm doing squaring. So what do we get as results? Instead of getting range 10, which is 0, 1, 2, 3, 4, 5, up to 9, what we will get will be 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on, right? It gives you the equivalent here. And this is how you would have written it if you wanted to just use the for loop in the purest vanilla form, right? You get the same result. As you can see, you get the same result if you start with an empty list and slowly you compute the square and you add it to that list. But list comprehension allows you to just write that in a very, very simple, concise way. You start with the formula and then you follow it by saying for n in range 10. The formula is n squared in this case. Okay, and it could, just like before, the n here, it's a variable name that you pick yourself. It's your choice. It could be x, it could be xy, it could be anything, whatever you want to come up with. Of course, if it's not one of the reserved words, that's super important to keep in mind. And then you just make sure to use the exact same variable name in your formula, whatever the formula is. Okay. I don't know if there's some questions that I should address. Shibl, they showed us, what if we want to skip every other number in the same range? How do we make that happen? Yeah, that's a good. I don't think I would go through over the question. I think it's a great exercise question where I give you a list of numbers and you have to skip every other number. I'll let you think about it. I'll let you think about the answer to that because it's super interesting. I think this formula here might help you, right? Because for example, if I want to start with all the numbers between 0 and 10, but I want only the even numbers or the odd numbers, you could try to think of the list comprehension to come up with a way to actually keep only the odd or the even. Try to think about it. Nice exercise.
And if you're stuck, why don't you can ask the question now over the break. Why don't you think it over the break? And if you're still stuck, ask us at that point. Okay.
Yeah. So over the break, I think it would be a really nice exercise to try it for yourself. Something that could also help, it's very good that they give this example here, is this additional thing. This is really, really cool, where now we combine both a for and an if into this list comprehension. So not only we have for planet in planets, similar to the way you saw it before, but now we also have the if. So we follow the for with an if statement, right? And essentially, this is a way of filtering out things. So in this case, what do we filter out? We filter out all the planets that have their word length is less than 6. Everything that is 6 or more, we skip. We don't print it in the short planets. It will not be part of the final result. So in this case, you're just the end result. Even though we start with 8 planets, you only have 3 of them that have the length smaller than 6. Okay, and remember, the way to do it is to combine the for and an if. You start with a formula, and in this case, the formula is just a planet because you don't want to do any kind of modification. You're not squaring or modifying it in any way. Then you explain the for. So what are you iterating over? What are you going? Which is the list that you're going over? And then the condition. Okay, it's very, very cool. And I think something like this could be used if you actually want to do what was described in the question. Yeah. Perfect. Wonderful. So I think right now there's a few other small examples that you can go over, but I don't think they're super super important for both for the exercises. So I will leave them. I don't think we should spend too much time covering the rest of it, but feel free to do it on your own time, and also to kind of, if you start doing the exercises and you get stuck, or you might feel that there's something that you missed, you might come back here, and it might all these examples might actually help you move forward with your exercises.
Yeah, one thing, just to comment on this is we created a Slack channel for all of you. The good thing about the Slack channel is we will continue to monitor it for 2 weeks after we finish this course. So you have 2 weeks to come back with questions you may have, and we will attempt to answer them on the Slack channel. After that, probably it might be difficult for us to do it because we'll get pulled into a lot of different directions. But do take advantage of the fact, you have some time to go over these exercises. And if you have questions, to come back and ask in the Slack channel. Either one of your colleagues, friends will answer it, or we will come in and help at one point for 2 weeks.
Wonderful. Okay, so before we go to a break, I'm just going to give one single example that kind of combines all this stuff, plus one of the questions that were asked earlier about return, because I think this one example kind of sums it all up into one function. So now, you see in this example that I'm giving here, I do have a return, okay? And the return is there, as I was mentioning before, because now we have a function. So now instead of just giving a few lines of code that get executed no matter what we have is a function definition, right? And when we do a function definition, we give it a name. So we start with def, we give it a name, and then we give a name of we give a name that will replace basically the parameters that will be given to this function, right? Then the colon, pretty much like for, if, while, def also gets a colon. And everything that is indented afterwards is part of the function. Okay, in this case, we have both a for, where we go over all the numbers in the list that is provided. We check if the number is negative with an if, colon, indent. And then what we do, we say basically here we're counting the number of negative numbers. So we increment n negative by saying, we have a new negative number. And once we're done, this is super important, we need the return function. If we don't return the function, then if you don't return the result, then the function basically did all the stuff for nothing. So the return is super, super important. We collect here the number of negative numbers, then we return it with the return function. And super important also, you have to make sure that the return matches the indent of the function. So it's always, whenever you have a function definition, then a for loop, then an if, you have to keep track of what's part of what, right? Otherwise, things might actually get messed up. And in many cases, it's a source of errors because, for example, I did something like this, where the return is part of the for loop now, instead of being part of the definition of the function, right? And how do I know if it's the definition of the function? Because it's the first indent from def. If I add it here, then it's the first indent for the for loop. And if I do it again, then it's part of the if. So where does the return belong? Super important, at least in this case, it belongs to the function definition, okay? So could we replace parentheses with brackets and vice versa? No, parentheses are reserved for function calls. Brackets are reserved, we have some curly brackets for dictionaries that we will talk after the break. And then we have the brackets for lists. So depending on the type that you're using, it's different things. So you will get errors if you replace them. But I mean, feel free to try it, and you will get some errors that they are really important. I don't really get what the return is for. Let's do an example just to make sure that we're actually understanding that. So I will remove the return just to see what happens. So we define the function, and then once we define the function, when you define the function, nothing happens. You're just defining it. You're not executing any code. You only execute it when you call the function. So how do you call the function? You give the name of the function, and you put in some parameters, in this case, a list of numbers. So let's execute this and see what happens. Nothing happens. Is it because nothing really happened? Well, the question is, something really happened. When you call the function, which means this piece of code got executed. It's just that the return was missing. So when I was done executing the function, nothing was given back, right? So now let's put back the return. Return and negative, right? We've redefined the function. So now the function is properly defined to return the answer. And once we execute it, now we have a 2 that gets printed. What's that 2? Well, that's the actual result. That's basically what was computed before. So that's why the return is important. Without the return, things happen, but nothing is given back to you, right? Given back to the place where you're executing the code, right? So basically here, if I want to store it and say, oh, I have 1x that will take the result of the function, right? This is where it's given back. Shibl, you want to add?
Yeah, the thing to remember is why do we have functions? So if you have, let's say you are writing code and you notice that you are repeating the same thing multiple times. So your code, for example, you are writing code about chess, and you say, okay, let me check if these two pieces can attack each other. And then you go down, and then you say, okay, let me check if these two other pieces are attacking each other. So instead of rewriting the same code many times, you write a function called are these two pieces attacking each other? So you create a function attack threaten. You create a function called threaten. You give it 2 parameters, which is the first parameter is the first piece, the second parameter is the second piece, and then threaten will return to you a Boolean. It will return to you true or false if they threaten or don't threaten. So now you wrote the function somewhere, and then in your code you are going to use this multiple times. So every time you use the function, that's when we say give it back. Is in your code you are calling the function, you get back the answer, and then you use it to continue your code. Then you might call the function again with other values, you get another answer, and that's given back to you. So that's what we mean by give back.
Yeah, so one last question, very quick. What is the red code for? So just to show you what the red code does, when you define a function, if you start with 3 double quotes and you start writing some text that becomes red, and of course you have to finish it by 3 other double quotes, everything in between those, everything that is red will be part of what help tells you about that function. So I mentioned at some point on Tuesday this function, this help function that basically describes what's happening. Usually to describe what happens is much better to have actual English than code. So in this case, the English part or the English description that comes with help whenever you want to know more about count negatives will be exactly this, right? So that's what the red code is. Perfect. Okay, so I think we'll take 10, and understand, if you want to try the exercises, perfect. Just so you know, when we come back, we're actually going to cover the 6th section a bit more, and when we're not do the breakout rooms where we actually. All right. So this is basically, this section talks a bit about strings, and which we talked to. I'm sure we've seen up until now a few, and we see even in the hour before we saw a few examples with strings. But just think of it as really like these are ubiquitous. There's everywhere. We work with strings, and that's normal because a lot of the things that we do are text processing. Just keep in mind that the best way to think about a string is really a list of characters. So anything that you can do with a list, you can do with a string. But just to be more concise, and to be easy to write and to put together strings and to process them easily, it's much easier to have a concise way to express these things, right? So the best way to do it is to put it between double quotes, right? The first thing to do is I start my double quotes, I put a bunch of characters together, I end the double quotes. Anything between the two will be a string. For convenience, there's this second way in which you can do it, where you can use a single quote. So if you use a single quote, again, everything from the first time you see a single quote until you meet another single quote, which is basically everything in here, will be equivalently called a string. There's not much difference, with one small exception. So one thing that you have to keep in mind, if you look at the two examples here, I'm just going to execute the code so we can see what ends up here, is that in the first one, I wanted to use a single quote as one of my characters. So if you want to use a single quote as one of your characters, then it doesn't really help to use the single quotes to separate the string, because then there will be a confusion, right? If I go by what I described and I said, well, from the first time I see a single quote until the second time I see a second quote, it's a string, then everything after that becomes confusing. It's like, wait, what's happening? Are you done putting together all the characters? Are you done describing a string or not? So to avoid that, this is where you would say, well, I want to have a single quote in my string. I'll just use double quotes to describe my string. The flip side is, of course, if I want to use double quotes in my string, right? If I want to use double quotes, as I do here with my dog is named Pluto, then I'm the kind of the reverse situation where I say, oh, I need double quotes in my string. Therefore, I will make sure to separate everything with single quotes. Keep in mind that whenever you write code in Colab and in many places, you will have syntax highlighting, this coloring of your code, which will make it clear whether or not you've written something that makes sense, or if you have this kind of weird things that are happening. So that's basically why you have both of them. It's really for convenience, pure convenience for whatever you want to do with your string. There's a third alternative, which is some people use it as well, which is this idea of escape characters. So the backslash, it's a way of saying, whatever follows after the backslash, don't think of it as ending the string. Really think of it as a character and keep on doing whatever you do. It's really, it's a subtle thing, but it does make a difference. So as you can see here, when you execute the code, surprisingly, even though I have single quote, a start and the end, what happens is because of the backslash, then the compiler knows not to think of it as the end of the string and really to think of it as a character that should be printed. So just keep that in mind. When you see this as a code, whether you want to use it or not, that's up to you. I mean, you always have the alternative here on the top, but just keep that in mind that whenever you see a backslash, then you really are dealing with something kind of like a hidden message, the compiler, when it comes to the characters that follow. To see this example even further, there's this, we're using again this backslash. So in this case, we have HELLO, backslash, and then N, followed by WORLD. So in this case, again, similar to the way use of the backslash at the top line, we look and we say, what follows after that? And basically what follows is an N, and internally the compiler has a way to interpret all of this backslash followed by something to an actual thing that changes the way that in which you see your string whenever you print it and whenever you process it. So in this case, backslash N is interpreted as a new line, right? So whenever we try to print this, we're saying, oh, I'm just going to print HELLO, then I'm going to skip a line, I'm going to go to a new line, then I'm going to continue with WORLD, right? We do that using this backslash. There's also, if you're really, because now you're saying, well, yeah, what if I want to print a backslash, right? If every time I have a backslash, everything that follows is interpreted into something weird, what if I want to add a backslash? The way to do that is to do backslash. So now what follows after backslash, it's a backslash, and that's interpreted as something that has to be printed as a backslash. A very subtle thing, but keep on playing with these things. And I think on the page they actually have a few more examples of interesting things that can be done here. But just keep that in mind whenever you read this code or whenever you want to do something subtle that somehow feels weird and it's hard to do. The third, and not the best, but still a good alternative, is to use the triple quotes. which is what we saw when we saw the comments for the function definition. And essentially, as soon as you start with triple quotes, then you can just free form write whatever you want, and the exact same way in which you write it will be printed to, will be part of that string. So here I just put a bunch of nonsense, and essentially the exact same nonsense gets printed the exact same way that I printed it. If I add additional spaces or new lines and so on, it will just be taken in exactly the way that I wrote it, right? And keep in mind that whenever you do this, whether you do it with the triple slashes or if you just do it with without it, using the double quotes and so on, triple quotes not, you will end up with the exact same thing. And the way to check that you get the exact same thing is to basically define it one way, define it in a second way, and just basically use the equal, right? Checking equality. We're checking for equality here. And whenever we check for equality of the two things, we realize that either way you do it, you'll end up having the exact same thing. Okay? All right. So last but not least, let me just print this one last piece of code, right? Where we go over a few print commands. We've seen this end before in the exercises before, but just to reiterate on what this does, you know, by default, whenever we have a print statement, what will happen? We will go over all the characters. You know, internally, it will do a for loop that says for every single one of the characters in the list of characters or the string, print that character. And then when you're done, go to a new line. That's why when I have the first two things and everything that we've seen up until now, once I'm done with the print, you realize that everything that happens after it's on a new line. It's on an additional line. So in this case, I will print hello, go to the next line, world, go to the next line. But now the third line, this is where we're kind of giving an additional parameter. We're giving additional information to the function print, and we're saying print hello, but do things differently. This time, once you're done printing hello, just have no new line, no space, nothing. Just make sure that everything that follows just gets added to whatever was printed before. So in this case, I will say print hello, then I will say Pluto, and as you can see in the output, it's Pluto characters, they just follow right after that. There's nothing in between the two, right? But of course I can change this, right? I could add dashes, right? And if I add dashes, in a similar way, essentially, once I printed hello, I add my dash, then I print Pluto, and I add the dash because that's exactly what I wanted at the end of the strings that gets printed, right? So it's not a new line, it's not a space, it's not nothing, it's really a dash. And, you know, feel free to play with this, but really, you know, anything goes in there. Whatever you're asking for, that's what you're going to get. And that's always at the end of the characters that you provide as a string, right? So keep this in mind. This is always used whenever you format the output and whenever you want to have something that looks pretty or whatnot. So this is basically this is also, all of these examples are taken from the page on Kaggle. There's nothing new that I'm doing here, but I just wanted to put them all concise so that we can actually play with them as we go along. I think we can share this collab, but again, anything that you see in your exercises, feel free to copy them and play with them, change the things as you wish and see what the output is. There's no harm at all whenever you work with these examples.
Gheorghe, there is a question by Ivan. He's saying, why no commas after each print statement? He's still confused about the use of commas.
Okay, we can add the commas just so you see what happens. Remember what I said, that commas are really reserved for lists. So in this case, it doesn't make a difference, right? When I say print hello and I put a comma, it really, for the purposes of what we're doing, where we just want to print stuff, it has zero difference whatsoever. But remember what I said, the commas are mostly reserved for lists. So if, for example, I want to do this, x is equal to print hello, right? And I try to assign it to something, basically, let's see what happens. We can just try it out, right? We get this weird thing, right? That says, oh, wait, what do you mean? X is now all of a sudden some kind of weird list that has none inside of it. So just to explain what happens here. What happens is the moment I put a comma, that's an indication that, hey, I think what you want is some kind of list. Otherwise, you wouldn't have put the comma. right? So it creates a list. And whenever you print something, what happens is the function call, the function print, will spit out all these characters and then will return none. It will not give you anything in return. And that's why at the end you will see, wait, X ends up being a list that has one element that is none, which is very, very weird, right? So it's not that they don't make a difference here for the purposes that we have right now. But if you put them in the wrong place, you might end up with something that you don't want to have, right? That's basically what I'm trying to explain here. It's really, they're reserved for lists or to separate. In this case, you can think of this as, I'm calling the function print, and I have a list of parameters that I'm giving to the function. And all of these are separated by commas. And you should only use it for that and for lists. Okay? I hope that kind of clarifies a bit more why we're not putting commas, but also why in this particular example, the commas don't really make any difference. Okay, so if there's no more questions, I'm going to share my other screen to continue a bit more and to talk about some methods that you can use for strings, right? We saw is upper, no, is lower, something like that at some case, at some point. But just keep in mind that whenever you work with things that are strings, there are special lists. There's special lists of characters where there's a bunch of things that are very commonly used, and you should use them as they come useful, as they come at use, and don't try to do it yourself by somehow implementing functions that might actually already exist. So the common things that are there is, for example, if you want to change it to all caps, right? The way to do it is to start with a string and essentially just say the name of that the variable where you stored that string, dot upper, and then the brackets. And recall why this is the case. It's because upper is a function. It's not just a variable name. Upper is a function that operates on claim. But the way it operates is instead of putting claim inside the brackets, you can just say claim dot and the name of the function. Just a kind of a backwards way of calling the function on claim. Similarly, you can do lowercase. So if you want all the caps to be turned into lowercase, you just say claim dot lower, or in this case, claim only because the variable name is claim, but you can put any variable that stores a string. There's also this very interesting one, which is it's quite useful as well, which is index, right? So if you give another string, what this function will do, whenever I say claim.indexPlan, it will go inside claim and it will try to see whether it can find this sequence of characters inside it. Is there something? Is there plan? Do you have plan inside this string that you gave me? And here we do have plan right here, right? So we do have plan because planet starts with plan, right? And what the function returns is the index, or essentially the place in the string where you will, this substring was actually found, okay? It can become very handy, especially, for example, if you want to see whether or not, like if you have a very large piece of text and you want to see whether some word is inside that text, right? That's super important. You might want to just jump directly there and skip everything else. And again, because it's a list, you can always jump in the strings and do whatever you want with it. One which is super useful as well is starts with, right? So if you want to know whether or not you, there's a sentence and you want to know whether that sentence starts with something. In this case, you want to know whether claim starts with Pluto, because the variable planet actually is Pluto. Then you can just say, does it start with Pluto? Yes or no? And then the return is going to be a Boolean. In this case, it's true because the sentence, the claim, actually starts with the planet name itself, okay? And you can do the equivalent with ends, right? You could say, does it end in something particular that you're trying to look for? So there's a bunch of really interesting things that you can do here. I'm not going to go through the entire list because I think the best way to do this is to try the exercises and to also try yourself to put in some variables which you might be interesting than these planets that are given here. You might have some more interesting things that you want to work with. Just try it out and see what does split do, what does starts with do, and so on. How are these things working? Because there's a lot of fun. It's just I don't think there's much value to actually go over every single one of them, other than to say that there's a lot of really interesting tools that you can use.
But this actually brings up a good question, which is, how do we know which tools are out there? How do you know which functions are available? Instead of design, this is actually a very, very good question.
Yeah. So I would say that in my experience, even when I was learning Python, just Googling what you want to do and adding Python at the end of the query, really, it's very easy to find answers quite quickly. So like, even if, let's say right now I've seen this and I know that this tutorial has a way to split strings or to search for stuff, instead of going back to the tutorial and trying to figure out, oh, how did the tutorial do it? It's much easier even for me to just Google it and be like, oh, I forgot how to do this. Let me just go and do it. And let me just go and search exactly what I want. Like, how can I split a string, or how can I put strings together or capitalize, right? It's easy to forget. But if you just Google it, honestly, you will most likely get an answer in the first few search results. And the answers are quite concrete. Like, they will tell you exactly the examples of how to do it. Yeah, it's a very good question. Yeah, so I'm not, again, I will let you play with this and with the exercises to kind of get a much better sense of what can be done with strings. After this tutorial, at least you will know things that are possible. So when you go back, when you search it, you know exactly that it's possible, but you just forgot the exact same way how to do it. So just go over this without having lots of expectations of like, oh, I have to remember this, otherwise I will not be able to do it. You will always be able to do it. Just Google it. It's very simple. Yes. There's a question that says, what is the best way to define a function? I think we covered that. There's a section on this. I think it's section 2, if you would like to know a bit more about it. It gives the actual instructions. So I don't think I'm going to go over it right now. But if you go back to section 2, I'm sure you will have a good answer to that. Or, of course, reach out to us on Slack with maybe some more concrete example of what exactly you would like to do. And we can help you out to do it the proper way. All right. Wonderful. So let's try to see now a bit more about dictionaries. What are dictionaries? These are the third type of brackets that you're seeing now. Remember, there's the regular brackets, the square brackets, and now the curly brackets. And essentially now, what we try to do with dictionaries, it's very it's very interesting. It's essentially, you're trying to find the most useful case for dictionaries is to think of it as having associations where you have one single word or one single number that kind of keeps track of everything else that is associated to a thing, right? So the best example is your students, and you know that your schools have, every single one of you has a student ID, right? So essentially any computer system will have some type of dictionary that says this student ID is associated with all this extra information and all these other things that are relevant for that student ID. And essentially, every time you want to access anything related to that, you will just use what we call a key, right? A key associated with some particular thing, right? So in this first example, what we use as keys are the string representation of numbers, and what you get back is an integer associated with that particular number, right? It's a very simple way. And the way to define it is now to have the curly brackets. You separate by comma every single one of your associations. So in this case, we have 3 associations, 1, 2, and 3. And the association is described by first giving the key name, colon, and then what is associated with that key, the value, what we call a value, right? So this is essentially how you define every dictionary. You give it a variable name is equal to, because you want to give, to associate with this variable name a dictionary, curly bracket, and then you follow key, colon, value, comma, key, colon, value, comma, key, colon, value, comma. See how this is second nature to me, so I just kind of know it by heart. But essentially, that's exactly how you define every single one of your dictionaries, right? A list is square brackets, value, comma, value, comma, value, comma, value, comma, right? When you have a dictionary, now you have to actually do this association, key to value. So how does that become useful? Well, the way it becomes useful is that now whenever I want to get something that is associated with that key, as long as you know the key, then you have access to everything else that is associated with that. Okay, so in this case, I would say numbers. Now, I know, weirdly enough, don't ask me why, I know it's very confusing because now we're using the square brackets outside of the context of lists. You would use the square brackets on the dictionary, and inside you would put the key. And once you get this, it looks like a function call, but it's not a function call because it's a dictionary. Numbers is not a function, it's a dictionary. So instead of actual brackets, you will use square brackets and you put the key value. And what you get when you do that, you get the value associated with that key. So this seems to be a way to define variables via code. What else would you use this? Okay, so I think Evan's question was answered, I hope. It's possible that it's in relation to the dictionaries, but yeah. Unless there's another question, I will move. Good, perfect. Yeah, so this is one way to define it. But of course, you retrieve the values by saying the variable name, square brackets, the key name inside. But you can also associate, so you can add new things to the dictionary. And the way to add new things to the dictionary is by doing kind of the opposite of that. And instead of just retrieving, in this case, you're saying numbers, the numbers with the key 11, I would like to associate 11 to the value 11, which is 11 as an integer, right? It's weird to read it out loud, but that's basically what this is saying here. So this will basically create an additional association in your dictionary. So your dictionary will have another key value association where the key 11 as a string will be associated with the integer 11, which was basically provided whenever I wrote this piece of code. Okay, and you can keep on doing this. You can keep on doing this even to redefine something in particular. So in this case, as you can see in the first dictionary, 1, the string 1 was associated to the integer 1. But all of a sudden I said, you know what, I want it to be associated with something completely different. And it's as simple as basically saying the numbers, in the dictionary numbers, I will look for the key 1. And I don't care what that was associated with before. From now on, I want it to be associated to Pluto, right? And that's basically the result. You will get the exact same thing with the exception that 1 is now associated with Pluto as opposed to the integer 1. Yeah, so it seems tricky. So the comment is that it's tricky. When would one use this in real life? This is very, very common actually, because so I think the one example that you could see, this is a very good example. And I mean, in real life, you will have something similar to this. As I mentioned, the example before with students, right? And the student IDs and so on, it's very common. Like it's very common whenever you have you call it a database, or if you have a large data set of things that need to have some associations, but you always want to retrieve them by a very simple key, right? In this case, it could be the name of a student or the student ID and so on. It's very common to do something like this when you have a dictionary, right? And then you just have the notion of a key. And then what you pass around is the key. If you want to, I just provide the student ID, give me the student ID, and all of a sudden a dictionary will actually have all this information associated with that. But I mean, it's actually quite common. And in general, whenever you have code for web developing as well, whenever you have some kind of properties associated with different elements on a web page, they're all in a dictionary because every property has a particular name, which is the key, and then it has some value that it keeps to that, right? And what we know, what we share in between programmers and what we know, it's always the key itself. What is the property that we want to change? Whereas the value can change all over the time and you don't have to memorize it, right? So dictionaries become quite useful in those particular cases. Yeah, I don't know if I hope that answers the question. So here's another example, right, where you can turn a list into a dictionary. So how do you turn a list into a dictionary? In this particular case, we would like to associate the name of the planet with the first letter in the word description of that planet, okay? So Mercury is associated with M, Venus with V, right? What I described is basically the output of the piece of code. And how do you do that? Again, we use, in this case, dictionary comprehension, similar to list comprehension, right? With list comprehension, if you remember, we had a formula, and then we would say for planet in planets, and then we would apply a formula on that particular and the elements of that list. What's the formula here? Well, the formula for dictionaries is always an association. That's where the colon kind of comes in. So here we will say the key is associated with this value. And that's the formula for creating an association in the dictionary, right? Mercury, M, Venus, V, Earth, E, Mars, N, and so on, okay? So that's how you use dictionary comprehension to create dictionaries. Speaking towards white space encoding, could you start Mercury on a second line? Could you start Mercury on a second line? Yes, you could. Yes. So whenever you define lists, actually, it's a very good question, and I think it's very important to go over this example so that that it's clear what we're going for. So let me share my other screen, my other tab, and basically follow the suggestion that was provided by one of you. So in this case, I would like just to make sure that it's visibly better and it's not weird, hard to read what I have in the list. I could do something like this. And this code actually executes, right? So keep in mind whenever it's always good practice to keep everything on one line because the rules are not super clear. And I think you will learn this on the fly as you go and you try things and you realize, this is actually not working. But just as a rule of thumb, whenever you define lists or dictionaries, you could actually, as soon as you open the list, it's very easy for the compiler to understand that until you close the list, I know what's happening. It's not going to be an if, it's not going to be another sentence, it's not going to be anything weird. It's really just a bunch of elements that you just put them on a separate line just because it's convenient for yourself. So you can do something like this very easily. And the same thing with dictionaries. And the list doesn't just apply here. You could have any kind of list of any kind of elements and it would still work. So that's it. So essentially, that's something that you can do. So let's switch back. Any other questions? No? Perfect. Okay, so similar to the list, what do we do whenever we want to see whether something is in the list? I'm sure you remember from Thursday. Whenever you want to know whether something is in a list, you would just say something as simple as, "Oh, this is the name that I'm interested in. Is that in the list? Yes or no?" Then you would just go, and if this would return a Boolean that tells you whether that's in the list or not. For dictionaries, what this looks for, it's a key. All right, so you would always say, is a key into a dictionary. And then once you know whether or not the key is there, then you can go and retrieve the values associated with that key by just using the syntax that I was showing earlier, which is this right here, right? The name, the variable name of the dictionary, square brackets in the name of the key inside there. So that's basically the one distinction that you have to list. So just keep that in mind. It's the same thing for iterating. Whenever we iterate over the list, it's obvious what we're iterating over is the elements of the list. But when we iterate over dictionaries, if I say for K in numbers, what you're actually iterating over is the keys in that dictionary, right? And then if you really want to get the value, you have to explicitly use this notion of numbers K to retrieve the actual value associated with that key. Just keep that in mind whenever you try to do things that are similar to lists, but not to dictionaries. But apart from that, they're quite similar. And as I mentioned, there are a lot of use cases and a lot of interesting things. I mean, I'm surprised I didn't give this example, but the word dictionary comes from the fact that dictionaries work the exact same way, where you have a dictionary of words and every word has a definition. So if you want to store anything like a dictionary, you want to work with anything like a dictionary, or think of Wikipedia where every article is associated with a full-length context, then you would use something like this, right? You have a single word or a very few words that describe what you're looking for, and then the full-fledged definition is the value associated with that. So just keep that in mind you know, a dictionary of words is a concept that it doesn't apply just to words in the English language or any other language. So just I think I will stop here when it comes to dictionaries. Similar to the strings, there are some stuff that I didn't cover, but I think in the interest of time and just to give you a bit more chance to interact with us on a general level, I will stop here. You will start doing the exercises associated with this section, and you probably will start having even more questions. Feel free to reach out to us. Feel free to look back to the tutorial that I just covered today, and maybe you know, follow it yourself slowly. And of course, don't forget, Google stuff. If there's things that you want to do, just Google it. And you know, Python is such a popular language that it's very unlikely that you won't find a good answer. Yeah, so I think for this last 20 minutes, 25 minutes that we have left, we were thinking, we were planning to kind of give it as a free time where you get the chance to either ask more questions related to the course or in general about Python. I mean, these questions came up already as we were going along. But just keep them coming more, you know, take advantage of the fact that I'm here, Shibl, Nabil, and others, and let's try to talk a bit more about, like, you know, why is this interesting, why is this cool, and how does Python actually make a difference in a programmer's life and in your life, the way it could have made a difference in your life, whether you're a programmer or not, as a day-to-day job. You know, I don't think you have to have it as a day-to-day job to actually do it for fun or for other purposes.
And if you have questions about projects that you want to do as well, we're very happy to answer.
Yes.
Yeah, and don't forget at one time to show them the wiki program you did.
Oh yeah, yeah, yeah. So we'll start with the questions, and then if there's not that many, there's actually a nice hangman example that I want to share with all of you. Oh, okay. So it goes like math import from math import. Yes, yes. So that's the last section, which we didn't really have the time to cover, but this is super, super important. So this is essentially, as the name implies, import. This is when you're importing things that already exist. So there are the keywords that I mentioned: for, while, length, help, and so on. These functions are kind of part of the core language, but there are so many other things that other people have done, which are not part of the core language, but you can still use. So math is one of these things, or any other library out there. So when you say from math import star, that's equivalent to saying go into the library, this library of things that were written by somebody else, and import everything. Star is kind of like a placeholder for everything in that library. And the moment you do that, that one single line will give you access to all of the functions within math. And again, to know exactly what that comes with, you can just go and Google Python library math. What does it have? And how do I use things in that library? Or in many cases, you might look for an example and say, oh, how do I compute this particular function in mathematics or probability? And somebody will give you an example and they will tell you, you will have to import math if you want to do this particular thing because it's not part of the core language. Anything that is outside the core language, you will need to have something like this. And there's quite a lot of things like this, just to answer the question. Yeah. But I totally invite you to go over the last section, because that section, if anything, the examples that they give are from math. And they talk about importing things from other libraries for sure. After we complete the course on Kaggle, do you know other online courses that teach Python in more depth?
Yeah, there's Coursera offers a lot of courses, Coursera and EDX. Those are very good sources for courses. There's a lot of other ones out there, like DataCamp might give you some free stuff. You have to go with what's available freely. Coursera is right now what I would say a very good source, because they have, with COVID, they're giving away a lot of courses for free.
And also, I think I gave the suggestion on Tuesday as well. I think it's good once you have this basics, you understand the basics and you pass this course, to kind of pick something more like a separate topic that is not just pure Python, you know, some other thing, interesting things that you would like to do, but you can do it in Python, and take that course. And that will force you to learn Python even better, but at least you're grounded into some other interesting things that you might want to learn about as well.
Yeah, when you have the basics, you can build on it. Usually a project forces you to learn what you need to do to get to results. Like, this is something that we always encourage students and newcomers into a discipline to do, is to do projects, because the project will kind of, you have enough motivation to get to the bottom of it. Let's say I'm very interested right now, I'm doing a project of my own to figure out the hospital occupancy rates. It's there's actually a lot of data out there the government gives out for free. Montreal has a lot of data that we use actually at the university to teach students what to look for. And so you look at, you know, you want to know what the bug bed infestation of Montreal looks like. You can actually go and check that out, and so you can do some analysis on the data, and then you can go and put it onto a map. So when you have a purpose, it guides your, you know, the steps you have to do to get there. I'll put the address for the Montreal data. And you can look for things called open data. Actually, Kaggle has a lot of data sets too, for that matter. The reason we introduced you to Kaggle is to make you aware of what's out there, and they have some basic things you can do, like the Titanic data set, etc., which many people use for experimentation and to understand what happened and who might survive, or to predict, to make predictions on it.
All right. So if there's no other questions, I mean, you can still ask. I'm not blocking the questions, but I'm just going to start presenting the hangman example which we will share with you, and hopefully you'll enjoy it and try to find a solution as well. Work on it. It's an exercise more than anything, and maybe some questions will come up on this, or if not, then you can also ask questions unrelated to this particular exercise. So here it is. I call it Hang Wiki. So it's basically a hangman exercise where the problems, or the words that you have to complete, are random Wikipedia articles. And again, this is more like, you can always change it and have your own vocabulary if you want to play this particular game with your friends. But I think it's just fun, and it's an interesting way to go randomly around Wikipedia and to learn about new topics. So this one is one of the examples that I mentioned before, where we have to import. And what you're actually importing is, think of it as the full Wikipedia. I don't know if it's the full, but anyway, some part of Wikipedia that you can actually explore and study on your own using Python, which is really, really cool. The way to do it is, there's actually a two-step here. First, you have to do this pip install, and this is because this particular module or this particular set of functions has to be first downloaded on the local machine that is running your code. And then once you have that, then you can do this import statement that was described earlier. And once you import that statement, then there's a lot of really cool stuff that comes for free, essentially. So one example that you can do is if you want to search, right? So if you want to search, this is very equivalent to the search that you get when you go on Wikipedia directly. You know, wiki.search Montreal, this provides, probably everybody can recognize what this is. It's a list. It's a list of topics, exact topics that Wikipedia has articles on and which match this search criteria. So if I search Montreal, you can see here the Canadians, you see the expos, you see Montreal itself, which is the city, you know, a lot of other interesting things that are there, right? So, and if, for example, you want to pick any of these pages and try to see the summary, you can just say wiki, which is the full library, the full Wikipedia library, and you can just say wiki.page montreal.summary, and that's a way to essentially get basically what you would get if you go on the Wikipedia page. But what do you get it as? Since we're in Python, you don't get a nice web page. You get an actual string of things. It's a very, very large string that describes Montreal, a small summary of the article. Right, so you would say, well, what's the point of this if I can just go on Wikipedia? Well, the point of this is that now you learn Python, and getting strings and lists and dictionaries and so on gives you the power to do everything that you've learned and to actually write code that will go through Wikipedia on its own and figure out things that you would actually otherwise have to do it yourself by clicking randomly on pages or whatnot. So this is quite powerful, and I totally encourage you to take this and play a bit more, if you're interested, of course, to do something like this, to work with something like this. And once again, try to look for Wikipedia Python library, and then you will get a full number of pages that explain exactly how to use the library in interesting ways that you might want to look at. So what I have here, it's a code. I'll go with the solution first, just to see what we would like to get out. So essentially, what happens? We get a random article, we take the title, and we take away all the alphanumeric letters. And then, I give it a chance to actually play hangman on this, right? So we will start with the letter A, and that will tell me that you've used the letter A already, and you have one single character in this particular query that has the letter A in there. And we start and we keep on going, E, I, and so on. And you can play this. I don't have any limit. I mean, it's a very interesting exercise to actually take this and make it a bit more interactive and have some constraints on it. It has no constraints, and if anything, as you can see here, it has a way out. So you can just enter star, and the moment you enter star, it will tell you what the answer was. Not only an answer to that, a small description of it, and it gives you the link to the Wikipedia page that actually corresponds to this article. Right? The answer was Paris Université Club. It's a rugby union. I mean, don't ask me why. As I said, it's a random page. The more you play this game, the more you learn how many random things are on Wikipedia, but they're super interesting. It's fun to play this. But the exercise essentially is, if you go through the process, I think right now you have all the tools to actually complete this exercise. I mean, the solution is right there if you're really curious to know and so on. But I think it's a really, really fun exercise to actually try to complete this thing. I give you just the first things that kind of set the game up, right? Which basically prints out the statement that asks you to complete the title, and maybe just gives you a hidden version of the word where every alphanumeric character is replaced with an underscore. So these are just very minimalistic things that are there for you to kind of start from something. But just have fun. Try to take this piece of code and try to complete and figure out a good way to have this nice interactive game where basically the code is waiting for you to give all the characters until you're completed. And now you understand this piece of code because we talked about it today, right? When we say while not completed, which matches very, very well our English version of what we're trying to do. So while you have not completed the game, you will keep on asking for new characters to complete the word. As you can see here, I have this, the special case where you enter the star, and the way it is handled is first you get the character, and then it says, well, if that character is star, what do we do if that character is star? We'll say, you gave up. You didn't want to complete it, but still, we will say that it was completed just for the purpose of actually, finishing up the game. So that's that kind of like the one particular case that was taken care of. What you have to take care of is, of course, the cases where you actually have a letter. And what you have to do is to keep track of all the letters that were entered and provided, and to make sure that all the letters that were provided by the user now get concealed. So whenever you print the word, you no longer print it in this way, where every single alphanumeric every single character from the alphabet is hidden, but now you want to print it only when it was actually given as an input by the user. So that's the interesting part of the game, and I invite you to actually complete the piece of code here. I'm totally convinced that you have all the tools to do this. So have fun.
Gheorghe, where are you going to share the code?
Oh yes, I shared it as a link on the chat.
Excellent.
Yeah.
Okay. We'll put it
Can
on
you
Slack
try-
as well.
Yeah, could you open it just to be on the safe side and see you can open it? I opened it earlier on. Right now I'm not able to. I'm not sure.
Oh, okay. So let me see. I reshared. Maybe the additional parameters made it weird.
And the second question, Gheorghe, is you're using Colab. Can you explain more what it is and how we can use it?
Yes, of course. Yeah. So Colab is essentially very, very similar to Kaggle. It has the same principle where you have a dedicated machine on the server that basically runs your code, and you have the exact same concept of cells where you run your code. I just think that it's basically a lot more flexible. And it has this one thing which I really, really like, and I haven't seen Kaggle do, which is it does the completion. So whenever, let's say if I do wiki dot, essentially it spits out this nice list of all the things that I can do with the library Wikipedia. And this applies to anything that you define. So if you define a variable list or whatnot, and you want to know what you can do, it just comes there and it gives you the help for free, essentially. So for example, there's this random thing I see right now. It's like set lang, which probably means you're setting the language. So you could set the language to French in Wikipedia. And probably once you do that, if you search, then all of a sudden you will get French articles, hopefully. That's exactly what happened, right? So see, like otherwise I would have had to go to a library and look it up myself. But in this case, because it was right there, and there's a lot of really helpful things like that work much better. It's also much more stable. I know early in the week we had some issues whenever we will try to do the breakout sessions. I don't think with Colab that would have happened. But the difference is that Kaggle actually provides tutorials, and whoever wrote the tutorial, they wrote it in Kaggle, so that kind of restricted us to staying there. But there's nothing that stops you from using Colab the exact same way as you've been using Kaggle up until now.
So Gheorghe, for a personal project, you recommend we use Colab?
I think so, yeah. Yeah. I don't think there's any restriction whatsoever. No, and of course, for people that are going to look more and more into to data science, if you're ever interested in the topic, I think Colab has a lot more, much better access to accelerators that do parallel computation in an efficient way. This is it's just kind of like a side comment. It's worth mentioning if ever you want to do that.
Yeah, we were asked if can you send the link to the videos? We sent the first 2 videos, so if you didn't get them, please let me, Z, know about it, because that means we don't have your email. But what it, we will update and send you the 3rd video as soon as it's available. It usually takes a couple of hours after the recording to be available.
And we should post it. So there is a Slack channel in case you haven't subscribed.
Yeah,
we will share them on Slack. And any question you have, ask it on Slack. For the next 2 weeks, we will answer questions. So in a way, you have free teachers for next 2 weeks. As well, Mingxi is trying to organize an event for us. So we'll email you. We're going to, as a thank you note for everybody who attended the class, we're going to create another event that is more not about Python specifically, but more about coding and doing projects in AI and these kind of things. Then we'll share with you if you are interested.
Yeah, so stay on the lookout for your emails. There will be a lot more coming through. And since the course is wrapping up, we're going to send you one last feedback just to know what you guys felt about this whole week of class and how it evolved over time. So I'm going to send you the link in the chat, but there will also be a follow-up email after today's course with more, with the link of the email and the link for the Slack channel if you haven't subscribed and all of that.
And we highly encourage you to finish. Sorry, Mingxi, go ahead.
And if you still have any questions for our instructor, we still have a little bit of time. If you want to ask it in person, but if not, you can obviously ask it on Slack.
Yeah, and we highly encourage you to finish all the exercises in the Kaggle course. And when you finish them, take a screenshot and post it on Slack. This way we will feel good about ourselves. We will feel that we actually helped you in something.
So we're open for questions at this point.
I guess we have time for one last question. So actually, I have a question for Gheorghe. Gheorghe, what do you recommend? Like, once I do this course, what kind of projects can I do to improve my coding?
I think maybe we should send this list of project ideas, because there's a bunch of resources online, like either particular projects related to specific topics. But I think we can just do something like, I think at some point we were discussing about this list of projects that are related to particular games, like Hangman is one of them, right? So if there's another interesting game that you're interested in, like Sudoku or some other stuff that is, you know, that you might actually understand it well, and you would like to, that will push you to understand both Python and other topics, then, you know, you're highly encouraged to do that. But we can send that list, Shibl. I think it would be good to share with people, and maybe they can have more ideas on particular projects that are similar to this Hangman example. I mean, I honestly, I encourage people to actually look more into the Wikipedia, because there's so many interesting things that you can do with it, and both with that or even Hangman, to make it even more interactive, because I just have some skeleton code, but actually a full-fledged Hangman game that it's fun to play and not just getting some random Wikipedia pages. It requires a bit of work and would push the boundaries. So anything similar to this, I think it's a nice way to move forward from this course.
Yeah, and I mean, basically the best way to learn programming is to do things, right? So
exactly,
I think it's good to do the course just to get started, but then do something that you actually enjoy, that you want to do. You can build a game, you can code Minecraft. By the way, there is a way to change things in Minecraft with Python. You can learn other languages as well. You can build web pages. So do things that you enjoy, and I think that's the best way to learn how to program, is you try to do something, then you blog, and then you search for it, you learn how to do that thing, and so on, and you keep improving your programming. So we are out of time. I just wanted to thank all of you for joining the class. I think it was lots of fun, at least for me. And I want to thank the instructors, Gheorghe, Amar, who was not here, and Nabil. And I want a special thank for Mingxi for helping us organize the course and communicating with all of you. Thanks a lot, and good luck with your.
Yes, thank you, everybody. It was a lot of fun.
It was, definitely. So keep going on Slack, and talk to you soon.
Bye.
Evan has a question.
So Evan is asking about SQL versus Python. Is that the question, Evans?
I wish I could help with that question, but my experience with SQL is very, very limited.
We use SQL to access databases. So if you look at Python, Python is you're building programs with it. SQL actually goes out and brings data from different databases. If you want a discussion on that, just send an email or put it on the channel. We'll talk about it later. They each have their own area of strength. I had discussions with Shibl a long time ago about SQL, so we'll have to resuscitate those. So thank you for everyone. What we'll do is we'll slowly drop and talk to you soon.